Hi, baby. How you doing? You want me to feed you, don't you? Yeah, you want to be fed. Hi. Good boy. Jerry Martin is first. Hello, Martin Critter. Video is gone. Says it's good on this end. No drop frames. Hit refresh. Miss Cool. How are you today? Yes, kitty, you're hungry, I know. Ah, you broke it. You broke it. Well, as long as you fixed it, that's what matters. Too cold. That's what your problem is. A guy's trying to print a fin on a rocket, and he's getting this on the edge of the fin. And some things that we know is that it's a 66-degree angle. He's printing the fin upside down, so overhang is not a problem. And 0.4 millimeter nozzle, 0.2 millimeter layer height, and he's printing in ABS. My guess would be his 80 millimeter per second outside perimeter speed is too high. And his hot end, either his temperature's too low or his hot end can't keep up. Um, and so it's under extruding at certain points of the print. And that's just more noticeable at the fin edge. It's just weird the way it's chewed up. That's weird. But my guess would be he's going too fast and not hot enough. So he needs to either increase the heat or lower the speed. That would be my guess. In fact, let's tell him that. God damn it. You son of a bitch. Really? It's too damn easy to hit the pause button. There needs to be a confirmation screen for that pause button. My fucking phone hit the pause button when I moved it. Why is it feeding? Because it wastes all that filament. Would be my guess. Could also be thin wall behavior. Yum, yum, yum. What's up? Ceiling? Now, I finally got the plug installed underneath my sink, so now when my sink clogs up and I unclog it, it doesn't dump all that water underneath my sink. And I also made a cat toy. Oh, he's gonna come running. Yep, here he comes. He knows the sound of this already. So I made a print in place cat toy. I took the artsy fish, combined it with my own handle, and combined it with a chain from the chain generator on Thingiverse, and made a print in place cat toy. if you want to pull the hair out of your skull and undergo a extraordinary amount of misery with first layer stiction, go ahead and try to print that. Because if a single one of those chain links comes undone, that's it. It's done. Hi, baby. Yeah. How you doing? Yeah. I know you're hungry. You gotta wait for Michelle to come out. Yeah. You're such a good boy. Yeah, you keep catching the mice, baby. Yeah. Go ahead. Always get a face full of cat fur. Actually, it reminds me, I got to install my cat corner rub later on today, so there's not too many corners in the house, but I want to put these on them so the cats have something to rub up against. Both! Well, this is the Explorer Aquarius. So this is actually a kit that Estes made, and I modeled it in 3D. And it only weighs slightly more than the kit. This weighs 141 grams, or 4.8 ounces, and the kit's only 4.2 ounces. So, not bad. Considering that the plastic model is almost as light as the paper model, I'd say I did pretty good. I don't know. These kind of models don't fly that great, but they're not supposed to. They're just supposed to look good. You know, if it gets off the pad and deploys the parachute, that's good. I haven't flown this yet because, I don't have the means or ability to fly rockets right now. But, yeah, I definitely hope to fly it this summer. It's amazing how simple this nose cone was. There's a version of that nose cone on Thingiverse, and it's a nightmare file. I mean, if you just want to print it, it's fine. There's nothing wrong with it. But if you want to try to edit the file, yeah, have fun. There's so many issues with that file. Even Mesh Mixer puked its guts all over my desktop when I tried to solidify the model. I want the vase mode printed. And oh, there's so many holes in the model. There's so many issues. I don't know if it's flip triangles, manifold. I have no idea what those things really. I know kind of what they mean, but I don't understand them on an engineering level. I don't understand them on a user level. I don't know what they mean as far as what I can do and can't do. It's like I understand what a fuel injector is, but I don't actually understand the fuel air mixture thing and how that works. I understand it's 13.7 to 1, but that's it. I have the paper knowledge, but not the real world knowledge. And the nose cone was a problem. I could not edit the file, and I didn't have the necessary knowledge or tools to fix the file so that I could edit it. And then I'm sitting here looking at this nose cone, and I'm wondering, can I reproduce this nose cone somehow? It looks like it's going to take hours. It looks like it's going to take so much work. And then, you know how I typically make my nose cones is I take a sphere or a hemisphere and I stretch it out. And I'm looking at this nose cone, and I'm like, nah. I was like, I mean, clearly, that's a ball. It's a sphere. And I was like, you know something? And this little cavity it's sitting in, that looks an awful lot like what a sphere would cut out of another object. And then I was like, and god damn it, this looks like a Big Bertha nose cone, a stubby nose cone, like a hemispherical shorty cone. And I was like, could it? So I took the nose cone in Tinkercad and I made a sphere. And the nose cone, I scaled it for this rocket, which is a little bit bigger than stock. The nose cone was 77 millimeters. So I made a 77 millimeter sphere, and then I began stretching the sphere north and south. And damn it to hell if it didn't line up exactly like a mold. I was like, no way. It's literally a 77 millimeter sphere stretched out, the bottom cut off, and then a cone stuck on the bottom. This is just a sphere, and then this cutout is just a sphere. The whole damn thing was 3 balls. I couldn't believe it. I was like, are you kidding me? This whole thing, I spent like 4 hours trying to edit this cone, trying to figure out some way of getting this cone into some kind of shape that I could edit it. It took me 15 minutes to recreate the cone from 3 basic shapes. 15 minutes. I'm both pissed off and impressed because the original creator of this cone was a genius. He just used 3 balls to make this cone. 3 balls on a cone, and then these little dimples on the side here is just a cylinder with a ball on each end. You know, that's super simple. I couldn't believe it. I couldn't believe it was that simple. I literally recreated the cone from scratch in 15 minutes. Less even. So, yeah, I was, wow. Oh, I'm actually thinking about, well, I was thinking about going into Fusion or Onshape, making a nice high resolution sphere, and then bringing that into Tinkercad and doing it again using a higher resolution sphere, because I would only need 3 simple shapes to do it, and then I could decimate the object in Prusa. Prusa Slicer is actually pretty damned handy. First, it has a direct connection to NetFab. I can send an object to NetFab and get it back. And it also has the ability to decimate objects inside the slicer, and you control how much decimation occurs. So objects I could not bring into Tinkercad, I can now simplify the object in Prusa Slicer, make it a simpler object, and you can even leave it at the highest resolution and it still massively shrinks the file. And to the point where I can now bring it into Tinkercad, and I can hardly tell the difference between the original file and the new one. So I might do that, but at this scale, you don't need to. Oh god, I can't stop yawning. At this scale, you don't need to, but if I want to make this bigger, this is going to start to look a little janky. It's going to start to look a little low poly. So I might want to recreate this at a higher resolution, especially since it was that easy. Yeah. In fact, I might even be able to take my model back apart and get back to the original size of these spheres, get the dimensions, input those dimensions, and make the 3 balls in advance, so I don't have to edit them and then just put them together in Tinker. But yeah, I was surprised by that. These were so shockingly easy to do. All these little cargo pods. I actually have are these single connection or dual connection? They are dual connection. So I'll show you. I might as well. Let's see, monitor. There it is, Tinker. This is actually a scaled down version. I'm going to make Micromax. I'm going to print this with a 0.2 millimeter nozzle. But what I did here is I have 2 ribs connecting this tube to this tube. And to keep it as light as possible, there's no cutouts inside this tube. So it's a single perimeter. And because it's capped on both ends, it's surprising. It's capped on both ends, and it's connected to the main tube by 2 struts, or whatever you'd call them, structural ribs here. And in order to make that printable, you see there's a little slit inside there. That's so that there is a valid path to come out here and print this portion here. Because when it's printing the skin, it prints this portion here. but I still need to print this little section in here. Well, I don't have to, but for rigidity, I want to. Because it wouldn't be as rigid if I didn't. So this cutout here allows the toolpath to path out here and print this portion here, and then go back inside again. So there's one of those cutouts for each of these. You still need your main cutout coming out of the model. I think I hid it. No, I can't hide it. It has to be exposed. So you still have your main cut to come outside and do the perimeter, but then each of these spaces here has an individual cut inside here to allow you to do this part. I could probably reduce the number of ribs in here since I have all these extra ribs, but it would only save like a gram of weight. The weight savings would it's just so small. So here, this one here, you can see I scaled it down. That's an actual quarter. So this would actually sit on top of a quarter. I'm fascinated by this now. I gotta go out. I think it's in the. Oh my god! I think it's in the minivan. I think it's left in the minivan from the last NARM I went to. Either the 0.8mm Ender 5 is in there, or the 0.2mm Ender 5 is in there. I gotta get that printer set up again because I want to start printing 0.2mm prints because this looks adorable. This looks absolutely freaking adorable. And in theory, this should weigh about 8 or 9 grams complete. 4 pieces plus a little caps. So what I do is I tell it to print a bottom layer so that it fills this in. And I use concentric infill so it creates circles. It looks a lot better that way. And then I can't do that for the top, however, because not only would that be a bridging action to try to bridge across that, but you can't have top layers below the highest layer. The only layer you can have top layers in vase mode, like I can have this have top layers, but I can't have this have top layers because it would have to stop the vase in order to print the top layer. But what I did is I made these little caps, and this just prints in vase mode. Each of these weighs like a 20th of a gram. They weigh nothing. It's so little, it's crazy. But that is these little caps here. So these little caps, and they just friction fit right in there. There you go. And now the tubes are closed, and you have the original model. I probably should glue them in. They do tend to want to pop out every now and then. I could make them longer so they won't pop out, but then I would have to use more mass. So I'll have to run the numbers and see what's heavier. Making these longer, like 3 times longer so they have more grip inside here, or a drop of glue. Because it might turn out that making these longer is actually lighter weight than using glue. So I'll have to actually test that, see which is heavier. But yeah, this nose cone is literally, it's literally just 3 spheres. Now I further modified this sphere. I cut this little section here out because this section here was horizontal, and you cannot have a parallel to the print bed surface in vase mode. Well, you can, but it's going to be an open hole. So I carved this out a little bit more so that I could print it in vase mode. So this is all printed in vase mode until you get to 95mm, and then that last like 6mm, that's in regular mode. But otherwise, the whole cone's in vase mode. It allows me to keep it really light. And then these pills are just a cylinder with half a ball at each end. And I even built the well, this one is solid, but on the big one, this one have it? Yes. So I put a hole straight through the entire nose cone, and then there's launch lugs on the tube, so the launch rod goes straight through the nose cone. This way you don't have to have standoffs. Because otherwise you would need like a launch lug out here on the fin, and then you'd have to have a standoff coming out from the body in order to clear the nose cone. So by having the launch rod go straight through the nose cone, I can just have my launch lugs down here, inside there, where they belong. I'm wondering how big I could print one of these. And how heavy it would be. Because I think it'd be fun to try to print a high power version of this, like, but print it. This one would have to be broken into 2 pieces, since it's already 100 tall. So if I made it 4 times larger, it'd be 400 millimeters. But I think I can go 500 or 600%. Well, we can test that actually. So the biggest dimension is this dimension. So if we were to take this, Control D, and if we were to do this and make it 300, look at the size difference, Jesus. That's 357 millimeters. So yeah, this one here would be over 800 millimeters tall. So that would have to be split into 2 pieces. But totally doable. So instead of being a 3-piece body, it'd be a 4-piece body. And the fins would have to be separate, of course. They couldn't be built in because that would be way bigger than the build volume. But yeah, in theory, I could make a... how tall would that be? That would be 4, 8, 12, 16. That'd be 2 meters tall. So that'd be almost 7 feet tall. That'd be a pretty big Aquarius. That'd be fun. Oh man, would that be big? I could print the cargo pod separate, and then I can make it even larger. But now all of them would also have to be multi-part pieces, and I would prefer not to do that. So I'm going to try to avoid that if I can. And if you guys saw my video Sunday, I made a cat rub in vase mode. So it only takes about 20 grams of plastic and prints in an hour and a half. And so that's a rub. You can screw it, mount it, glue it, double stick tape it however you want. I got tabs on the end so you can screw it in if you want. And that's all print in vase mode, so that's a little rub. Cats like to rub up against stuff like this on the wall. So the kitty cats will enjoy that. And you probably also saw that I made a tie. So I made my own flexi tie. The one flexi tie I saw, it's got scoliosis though. For some reason it curves. I'm not sure why it does that. It didn't come off the printer like that, but it's curved. But I did so that I can customize this part, put whatever logo I want on there. It's got a magnet on the back. So for example, actually I can show you. If you're wearing a collar-free shirt, you just take 2 of these magnets, like that. And what you do is you put one on the inside of your shirt and one on the outside of your shirt. Like that. So now you have a mag mount on your shirt. It's got to be straight, of course. And now you just take the tie and stick it to your shirt like that. So now you have a magnetic tie that you can pop onto whatever shirt you want. You just have these 2 magnets sitting on your shirt, and then it just sticks to it like that. And so that you can wear your 3D printed tie. And if you want to wrap it around your neck, there's a channel through here. Put elastic, ribbon, string, paracord, whatever, and then you could put it around your neck. But I thought that was pretty cool. Plus, I can make it longer by designing it myself because I have a big torso. I'm 6'4", but I have a 27-inch inseam. So, big torso, little legs. So I can make it long enough to where it properly fits a person like me. And if you need shorter, you can just remove a couple links. And the links it's just filament. You just stick a piece of filament right through, and that creates the hinge, you know, when you print it. But I'm really pleased how that came out. His was marked as non-commercial, no remix, no derivatives. And I was like, fuck that. I mean, when you're someone like, you know, Fontus Mint or somebody like that, and you're making some really impressive art pieces, okay, I get it. But when you make a goddamn tie and you tell everybody, you can't remix this, no derivatives, no selling it, and like, bullshit. So I made my own and released it. So you can do whatever the hell you want with it. As long as you give me credit. But yeah, I did that in Tinkercad. That was surprisingly easy. And then where's the cat toy? There it is. But that actually came out really cool. I did mine with no top and bottom layers and hexagonal infill. So you can actually see the infill pattern through it. It took me a while to figure something out. This is in 3 chunks and 4 with a knot. So here, I'll show you. So this is in 3 chunks. 1, 2, 3. They're all separate pieces. You could actually, and I might do this one day just because I can. I might create an STL file for each and every single link for the sole purpose of every time I put a new roll of filament in the printer, I'm going to print a link segment with that new roll of filament. So eventually I'll have a tie where every piece is a different color. I just think that would be badass cool. So I'm going to do that. You can see I made flatter ones so you can put logos on it. So here's the Lucky Cat logo, and here's the Stargate symbol for Earth. And then you have this one, you can put whatever you want on it. Use my video on converting JPEGs to SVGs. So actually, I might as well show you. So let's say, what's a good one? What's a logo? Pick a logo. I'll let you guys pick a common logo. You know, like Ford or Chevy or a bank logo or whatever product logo, any kind of logo you want. You know, the Star Trek Delta or something like that. You know, whatever logo you want. Actually, let's do the Star Trek Delta. Oh, Toyota. There you go. Add the word clip to whatever logo you're looking for, and then click on images. And what you're looking for is a flat 2-dimensional logo like this. Perfect. Okay. And you're looking for clip art. You don't want shaded ones like this. You don't want 3D ones like this. You need it to be a flat, basically 2-color image. Doesn't matter what color it is. You can convert it to black and white if you want, but the closer you can get to a 2D image, the better. So let's call that Toyota. Okay. I did not mean to do that. History. I don't want this many open. Okay, so we got rid of that. What we do is PNG to SVG, and you're going to see a site called Convertio. Let's see. Convertio is the one that I prefer. There it is. Convertio.co. And that'll take you directly to PNG to SVG. We're only doing that because the Toyota logo is a PNG, but you can do whatever you want. Oh, wait a minute. How big is that file? Okay, it's way small. You can't be over 1,000 pixels, or you won't be able to import it into Tinkercad. So that's an important thing to remember. Why is this here? This other window was open. And then we hit convert. Yeah. There we go. Download. So now you have this Toyota SVG file. It's got to reload all the tabs to accidentally close the window. So this is 10.31 millimeters tall. So we're going to go to that height. Import, choose file, and you can choose the Toyota SVG file. There you go. We now have a Toyota logo as a 3D file. Now remember, if you hold down the Shift key, it'll keep the dimensions proportional. So it'll correctly shrink the file for you. 10.31 minus 0.6 would be 9.7. So we're going to lift it up to 9.7 millimeters. This way it'll be 3 layers embedded into the model, which is what we want. Turn it into a hole. And that looks pretty good. You can also align it. So let's center it. Let's bring it down a little bit. There. And now when I merge them together, I now have the Toyota logo embedded into my file. Now make sure you use at least like 5 bottom layers so that you have a solid layer underneath this, or top layers, I'm sorry. So you have a solid layer underneath this, but that's it. Now you have the Toyota logo in there. So now we have Toyota, we have Stargate, and we have the Lucky Cat. And you can change this up anytime you want just by removing the filament pin and swapping out this piece of the tie. You see I built, so you got the hole there for the filament to go through. This is a hole for the neckband to go through, or you have the cavity on the back for the magnet to go into. I like magnets, so. It was surprisingly easy to make. What I did was I made a rectangular segment, and then using, with tolerances built in, I made these individual cutouts in it, and then I figured out how far I needed to move one. It happened to be exactly 27 millimeters. So I grabbed one, moved it 27 millimeters with Control D, and then I just kept hitting Control D, Control D, Control D, Control D, Control D, Control D, until I had one big long square rectangular tie. And then I used a cut tool to cut the shape of the tie to give us this shape, including for this. So this is actually a link that's merged with a triangle. And then I broke it into 3 pieces so that it's printable, because if you grab these 3, you can see it's 199 by 197.8. So this will fit on any standard print bed. Now, these are actually separate. You could, if you want, separate these. I wish there was a way to do that in Tinkercad. Separate connected parts in Tinkercad. There's no way to do that. If I want to separate this into individual links in Tinkercad, I have to use blockout tools to delete the portions I don't want. There's no way for me to tell Tinkercad, I just want to split this up into its 7 constituent parts, because it is 7 constituent parts. They are separate. Oop. So you can see here, they're not connected. But I've told it they're one object in Tinkercad, so that's the way it does it. Now you can, of course, bring up Simplify 3D and say separate connected parts, and then save out each of those individual STLs. And that's what I'm going to do. I did this to make it easier for people to slice. Now the reason this was one piece, this whole set here was one piece, so it was 2 STL files, one with these 3 sections and one with this piece here. I found out I can't do that because when the slicer calculates infill, it calculates infill for the entire object. And I wanted the infill, since I'm going to be displaying the honeycomb infill, the hexagon infill, I wanted it to be centered. And there's no way to center it because it starts the pattern here and ends the pattern here. So the only way to get centered infill was for these files to be separate. And then I create a separate process. And now when I create the infill is centered on that one single object. Because it was centering the infill on the conglomeration of the 3 together. So by doing these as separate pieces, I was able to have the infill centered on all the pieces in a line. Now, of course, if you're printing... If you're printing these with top and bottom layers, then none of that matters. But I wanted to print it with no top and bottom layers. I wanted to do that, you know, show the infill technique, you know, where you print it, where you can see the infill. And so for aesthetic reasons, I made them separate pieces. And later on, I'll probably come back and add a bevel. If not to these pieces, at least to this piece down here. You know, give it a little bit of a bevel. Not much, just a little bit. But it's so thin. What is this, 8 millimeters? 7 millimeters? 7 millimeters. It's so thin that it doesn't really need it. And the other cool thing is, that technique of using these symbols, you can do that for every one of these. You can add whatever symbols you want to any of these using that same technique. So I can get a whole bunch of different cat logos and put cats all over this. I can put all the different Stargate symbols on this. There's 21 here, so if I put 2 Stargate symbols on each of them with 3 on this last one, that's 43 Stargate symbols I can fit on here. I think there's only, was it 39 or 47? I forget how many there are. But or different car logos, all the different teams that you like or whatever, you can put all that on here, and or put dates on here for different events. You know, you can do whatever you want. It's kind of interesting. You know, the tie becomes a blank slate to do whatever you want. So I was kind of having fun with that. But that is on Thingiverse and on printables. And of course you could 39. Okay. Oh man. So you'd have to do 3 symbols per segment, and 2 for the smaller ones. And or all the different gold house symbols. You can put all those on there. And just fun things you can do. What is that? Different interesting things. Oh, you guys. I'm printing the Starlight rocket. I'll show you what it looks like. Actually, I think it's the Astron Starlight. Yeah. So you got that one. That one. Just bringing up different pictures. Yeah. Good. So here's the Astron Starlight. That's that one right there. And to give you that's a little hard to see. So here's another picture. Jerry said hello. Jerry, one of my viewers. So this is the Astron Starlight. You see the fins go all the way to the top underneath these two rings, and then it has these radiator heatsink fins here. It created some challenges in how to 3D print this, at least in the way I like to 3D print, phase mode, because you can't phase mode these fins, at least not integrated into the rocket. So what I did was I drew a line from here to here, and I chopped the fin off, and I created a socket in the model, and that socket will accept the fin. So that looks like this. I've reached stage 2, where I've got most of the modeling done, and now I'm printing the parts. And if that works out well, you go on to stage 3, get somebody to flight test it. So I was able to make it into 7 parts. Well, 4, but one of them you have to print 4 times. And that's what I came up with. So this will thread into this will fit into this, and this here, this fin, has a socket on the end of it, is a curved part. I added my ridge line reinforcement, and I also put a full ridge of this entire section here that actually connects to this piece here, so that the tip will be reinforced as it's going to hit the ground first. And then on the body, you see the fin is a weird shape. And that's because this fin will glue right into that socket right there. So that socket right there, the fin will glue into. Now, something I should have done and I didn't, I should have put some kind of tabbing right here on the ring for the to help guide the fin when you glue it on. So 2 little nubs sticking out here to help center the fin in the socket. I kind of have it on the fin itself. Why does it go so slow? So you can see here, this rail here is actually smaller than the fin, so it has these little edges that stick out, and that'll help straighten the fin. But again, that might be noise. It might be so small, it might be noise. And then that's it. You'll be able to print out this 4 parts, print this one out 4 times, and you'll have a 1.2 meter long, 3-inch class Starlight model. And then, of course, some annoying pest on the rocketry forum felt the need to torture me, and he posted this variation of the model called the Mars Probe. So, of course, I now have to make this one too, because that's just freaking cool looking. I absolutely have to have this. So now I'm making one of these too. The first piece is already printed, but it's not perfect. So this is the first piece. So this is where the motor will be, and this is that beginning ring. And then another piece will attach to bring it back down again, and then the next ring will be here. Oh, you can try. I bite though, so be careful. But as you can see, it's not straight. And that's because it pulled off, even with all of my tabs, even with all my mouse ears around the whole thing, it's still warped. And this is PLA, but it's still warped. You know, I had like 20 of these. Yeah, I bet. Well, wind doesn't bother my range too much, but I drive slower. So, yeah, at 75 miles an hour, that wind's brutal. So I had a whole bunch of these little mouse ears holding it down, but it's still warped and pulled away from the bed. And normally, I don't care. When a part warps like this, it's okay as long as it doesn't really destroy the part. The problem is, this is a a mating surface. Another part has to mate to this surface. So if the ring is warped, that's fine. But this fin can't be warped because you're gonna know it. These two parts are gonna go there, and you're gonna see this nasty gap. So I've got to reprint this so that I don't have that gap. I guess I just have to use a full-on brim. I was hoping to avoid using a brim, but it looks like I have to. You know what's interesting is that technically this is the outside because there's a cut in this ring to let the nozzle get inside here. But the slicer is smart enough to only put a brim on this outside edge and not put a brim all along here. I actually kind of wish I can get it to do that because that would hold it down. So I've got to figure out how to fix that. This part feels heavier too. It is bigger, I guess, but it just feels heavier than I thought it would feel. So that's the bit, and then here's where the fins are going to attach. You got these little tabs here. There'll be a slot in the fin, and then the fin will just slot over top of the tab there, and then you glue it in place, of course. That's a big difference. That's a... Wow. That's a huge difference. That's like, what, 40% increase in power consumption? So I got to rework that one, figure out how to get that to play nice. But I finished the rainbow filament one. I told you I had that one roll of transition PETG. I finished it and it worked. It's not glued together yet, but that came out absolutely spectacularly. I just cannot believe how nice that came out. And shockingly light. This whole thing weighs 480 grams. For a rocket that size, that's actually pretty light. And it's 3 pieces. This piece, this piece, this piece, plus the internals. Yeah, that's incredible. That just look... No, I haven't been using the CR30 lately. I have it right there. For the stuff that I want to do on the CR30, I need to use the CR30 outdoors, and that's not going to work in the wintertime. It's just never going to stick to that bed when it's 10 degrees outside. So I have to set it up outside. And, want to sell it? No. No, I don't want to sell it. That's a printer I couldn't replace. But I have two 20-foot roller beds, or 10-foot roller beds for a total of 20 feet. So I have two 10-foot roller beds, industrial roller beds, and a table that is adjustable. I have an adjustable electric table so that I can have, yeah, the wind is annoying. If I had this all to do over again, I would probably try to get someplace in Rio Rancho or Las Lunas, just south of Albuquerque, Belen, stuff like that. I would probably try to get a place down there, Bosque Farm or something like that, because the first of all, the winds are brutal. I mean, like today, it's crazy. It's so windy, and but also the cold. That 1,800-foot elevation change makes a big difference in the snowfall and the temperature. It's on average 10 degrees warmer down mountain. Oh. But I'll probably never be able to move again. I'm probably here for the rest of my life. But if I do have the opportunity to move, that's probably what I'll do. I'll move to the outskirts of Albuquerque. Probably further from Albuquerque than I am now, but it'll all be flat ground. So I won't have that 1,800-foot elevation change. And, but yeah, I mean, it's beautiful here. Don't get me wrong. It's absolutely gorgeous. The crime is low. There's not too much crime here, but well, the problem, I don't mind the cold. The cold's expensive. My $5,000 triple head mini split failed, and so I had to use one single resistance heater to heat this house. So my average temperature in the house was 50 degrees. That's cold. You shiver. There's quite a few streams the last couple weeks where I was sitting at this chair right here shivering because it was cold. And I couldn't turn on a second heater because they cost $170 each to run them. Each of those heaters costs $170 to run. It only cost me $50 to run the heat pump. But it failed. So I gotta hope I can get a hold of the damn guy who installed it and hope he honors the warranty. Yeah. Yeah, they tried to rob the, for those who don't know, they tried to, yeah, your jackets help, but only to a point. Cold is cold. Eventually that cold soaks into you. But that's what we did. We ran the one heater to keep things from freezing, and then we dressed warm. We stayed in bed. We used the electric blankets. That's what you got to do, If it got really cold, I have an emergency reserve heat source. So I have a kerosene heater, and I have 30 gallons of diesel, which is enough for 15 days. It's not that hot here. In Edgewood or in Albuquerque, it doesn't really get that hot because even Albuquerque is still 5,000 feet above sea level. So that tempers the heat. Yeah, I'm from Pennsylvania. Yeah, well, Phoenix is fucking hot. All right, Phoenix, the asphalt can cook. The asphalt can cook you. But around here, yeah, the 90 is your typical max, and because the air is so thin and the humidity is so low, that as long as you have any kind of shade, it's really not bad. Now, if you're out in the sun, it's gonna bake you. It's gonna cook you. But if you can protect yourself from the sun, it's really not bad here. Even when it hits 100 degrees, it's not bad. And of course, the moment the sun breaks that horizon, it's like 70 degrees outside. It's wonderful. So there are definitely huge benefits. Phoenix is just hot. It was hot in Flagstaff. Flagstaff I thought was higher elevation. I looked at Flagstaff because it was, when I was there, we saw the Grand Canyon. It was beautiful. But yeah, you see house prices in Flagstaff? You're looking at $500,000 for a shack. See, I hate that. I hate when I'm surprised it's that hot at night in Arizona because it's low humidity. Wow. No, it's never that way here. It's 60 to 70 degrees at night. It's wonderful. Yeah, 100 degrees at midnight sucks. I bet you it's not that way out in the desert. I bet you it's only that way in the city. Yeah, Tucson makes more sense because Flagstaff is high elevation. Pine trees, snow, winter. Flagstaff would be colder than here. I was looking at Tucson. I couldn't live in Tucson, but I could live in Sierra Vista, which is south of Tucson, right on the border. There it goes. Because Phoenix is just fucking hot. Tucson is much better. It's still hot, but it's not bad as Phoenix. Yeah, I would not want to live in Phoenix. But I bet you Phoenix is so hot because of all the concrete. I bet you if you were outside the city, it would not be nearly as hot at night. Still gonna be hot as fuck during the day. But although sand is a good heat battery. So it might be that hot even outside the city. But here, the moment the sun goes down, it cools down. And it doesn't actually get cold here. But it can. They've had 40 below zero here. But your typical winter, you're looking at 40, 50 during the day, and 5 to 20 at night. which is really not that cold. If you come from any place like Pennsylvania, you know that's not that cold. They every year we do have a couple of really cold nights where it gets like -8 degrees, but that's usually 1 or 2 nights. This winter was longer than most winters. Like it's usually warm now. It's not. It's still cold. We're just starting to touch mid-50s now, which is really annoying because usually it's a lot warmer sooner. But temperature-wise, we had a very mild winter, which is fortunate because I had no heat. The first half of winter was great, but when that thing failed, that sucked. I got to figure out what to do for next year if I can't get the guy to fix that because I have no money to repair it. If I can't get him to honor a warranty, then I'm fucked. I have no heat source for this house because I cannot afford to run resistance electric heaters. They cost too much money. I got to figure out another heat source, a way of collecting more diesel fuel. It's not that crappy. I mean, well, I guess compared to a major city, it might be a bit of a different vibe. But as far as just in general, Albuquerque's not that bad. It's actually quite pretty. There are certain parts of it that look a little run down, but none of it looks as bad as the bad parts of Philadelphia. Now, of course, the best place to live is North Valley. If you can get a place in Corrales, that's a nice area. That's a nice area. Low crime, lots of resources available in the area. Corrales is the sweet spot if you could find a place in Corrales, but it's also pricey. Down south of Albuquerque, I heard is not too bad as long as you're away from 25. So if you live on the outskirts of Las Lunas, Belen, or Bosque Farm, I heard that's pretty good. But then resources are more difficult. It's going to be harder to get community water. It's going to be harder to get broadband internet. Live in the north end. Wow, I loved Tucson. But then again, I was just visiting Tucson and I was in a hotel room. But the 2 times that I remembered going to pizza. I don't know about the crime. That probably depends on where in Tucson you live. But I remember visiting Tucson. It was gorgeous. Every goddamn night. The sunsets just got better and better and better. The sunsets kind of suck here in Edgewood. And that's because the sunset is blocked by the mountains. So to get to Albuquerque, you have to actually go up a little bit and then down. And so we have that mountain ridge to our west that blocks the sunset. Yeah, you bought the house that was on Breaking Bad, and now you're pissed off about it. Okay, it's one thing if if you had that house before that, but you bought it afterwards knowing what it was, and there's no way you couldn't not know what it was. It's like, on the one hand, people should leave her alone, but on the other hand, she's kind of cuckoo. Oh, oh. Well, that's even worse. She leased it to them for a TV show. Unless the craziness is on purpose to draw attention. Okay. Cool. Yeah, I know there's a fence around it now. And if you so much as look at it the wrong way, apparently she comes out screaming. People are going to stop by. It's an attraction. What she should do is get a goddamn business license from the city and put out a little souvenir stand out front. Make some more goddamn money off of it. That's what I would do. Hell, I'll sell her some 3D printed Heisenberg busts. But that's what I would do. Well, she's not going to get rid of the attention. it's part of an extraordinarily popular TV series now. It's part of pop culture. There's nothing she can do about that. Sell the damn place and move. Hey, Pedro, how are you doing? So far, this is working. The one in marble ended up fitting, and kind of fitting. So I've got that installed. So no more like when I put all the Drano and stuff in there, and I finally got the sink to unclog, it all poured out underneath the sink because the sink is higher than the opening, and so more of the water came out of that opening than went down the drain. Is a improperly installed dishwasher drain. It should have been sealed with a vent. And also, now it's sealed. Nice. Exactly. That's what I would do. Make it a tourist attraction. Put out a stand out front with information. I'd make the house as close to the TV series as I could. I wouldn't change a thing. I'd probably even put my own pizza up on the roof on purpose. I would have some local metal shop make me a metal pizza, and so it looked like it came from the movie. And for some reason, YouTube blocked that comment. That is not a comment that should be blocked. Well, I wouldn't let them throw pizzas. That's going to cause a mess, and I don't want people in my yard. If people didn't respect the yard, I'd put up a fence too. But out on the sidewalk taking pictures, go for it. I'd have somebody make me a pizza prop, and I'd permanently mount it to the roof so that the pizza prop is always up there for people to take pictures of, because that's what they want. That's what they're there for. That scene. Yeah, she should milk that shit. I would. Hey, DeWitt. Exactly. I don't know if I would do signs. I'd make them very small because I wouldn't want to ruin the picture with signs all over the place. But digital signs, like for example, maybe put a path. If people were respectful, put a path through the yard, a stone path, and then as you pass certain points, you would trip a motion sensor, and a little thing would start playing, telling you this is where this happened, and this is where this happened. If you look up above you, that's where he threw the pizza. Stuff like that. I would even go so far as to getting a car like he had, and just leaving that car parked in the driveway. Yeah, I'd try to get like a driveway out back where I could park my cars, and then leave the Heisenberg car parked in the driveway. And maybe have somebody with an RV stop by every now and then. Milk that shit, man. It'd become my job. But different people. I gotta see. There's a guy who made Paul the Alien, and he's got the finger, and I think it's only under a Patreon, so I gotta find out who has that, and see if they'll let me buy the file, because I can't afford to join anybody's Patreon. But I want to get that file, and I want to print out a life-size one and put it out the street. Is that what it was? I thought it was a station wagon. Was it an Aztec? I wonder what her property taxes are like. Because I can see an argument in both directions. On the one hand, you could argue the value of the property is higher because of its presence in the movie. But on the other hand, you could argue that because of all of the attention that is drawn to that house, that its value is lower. Because it's a nightmare to live there if you don't want that attention. So you could argue both ways on that. I wonder what her property taxes are like. One more reason to abolish property taxes. They shouldn't be allowed to do that. But what are you gonna do? Eat them. People are weird. Cool. I haven't watched the whole series. I'm pretty sure I made it through season 1, and it was good. It was entertaining. I liked it. I just never got around to watching the rest. Although I'm interested in seeing that new Tulsa King show. I want to see that too. So this part will be done in 7 hours, and then if it looks right, I'll print the second part, and then I'll start printing the fins to put it together. I did have one problem with PETG. I think printing the motor mounts in PETG is too soft. I don't like how squishy it is, and the layers don't quite bind right. So I think if I'm going to make a PETG motor mount, I'm going to have to do 0.2 millimeters, not 0.3 millimeters. The layer bonding is not good enough for 0.3. And I'm also going to double the number of ribs. So instead of having 8 ribs, have 16 ribs. PLA, 8's fine, but I think for PETG, I need to go with 16 ribs. And this also, this top layer here didn't bond. It didn't seal together. No new printers. I got a couple printers I'm eventually going to dig out. Like I did buy one of those 334s that Monoprice made. They didn't send it to me. I bought it a couple years ago. That's sitting in my closet. I got to break that out eventually. And actually, I should get that out because I need more 334s to print these rocket parts. And then I also have the what is it? Something aqueous Aguilera. It's a little box printer like the FlashForge. Well, you use that Filamentum makes it. The glacial blue, that translucent, really nice glacial blue from Filamentum, that would make some pretty good candy, meth props. So that's like a little FlashForge. I have that one. I'm also probably going to be building some of the box printers that I have. Like I still have Ender 2s and Ender 3s still in the box. And I need some of those printers running. So I'm going to probably build those over the next couple months. Especially the Ender 2, because the Ender 2 can actually print any of my 80 millimeter parts that don't have fins. As long as the part doesn't have fins, like the nose cones, the body tube segments, nose segments, couplers, stuff like that, the Ender 2s can print those. And because it has a 225 millimeter tall build volume. Yes. Yeah, and if you have a micro center near you, you can still get the coupon to get an Ender 3 Pro for $99. And that is still by far the best bang for the buck in 3D printing. I mean, I think the Ender 5 is better product, but as long as you know how to assemble it straight and true, the Ender 3 is untouchable at that price. Nothing can touch it. And and one of the reasons I like that printer, I mean, I had a hand in designing it, but one of the reasons I like that printer is that it's stupidly simple. No. Micro Center does not. I think the nearest Micro Center is up in Denver. Let's find out. No. When I'm done. Okay. No, I never did get that done. No money. I got lights for it though. And in fact, as soon as this cold weather goes away, that's going to be a project. I'm going to get those lights installed. Over Christmas, Walmart had linkable 4-foot LED light fixtures for $10. I was like, hello. I bought enough for 2 for each container when they were $20, and then they lowered it again to $9.97, and so I bought 4 more. So now I have enough to I think I have enough to do 3 or 4 in each container. So I'm gonna have a set of and they're motion sensor. You can set them up to be motion sensing. So I'm gonna set up I got magnets to hang them. Set up a string of lights in each container, and then I'll just use one of my battery boxes. I just go out there, plug in the battery box, done. I might even leave a battery box out there with a solar panel outside to keep it all charged up. Eventually, I still want to open up those containers for more space, to make it into a large room instead of just individual containers. That's going to take a lot of work. Just a lot of work. Yeah, it looks like the nearest micro center is, well, if you're out in California, there's one in Los Angeles, down by Irvine. But otherwise, you're looking at Denver. Yep, south end of Denver, there's a micro center. That's the nearest one. And then you have to cross the ocean to get any more, the land ocean. You know, like I said, the next nearest major city is Denver or Oklahoma City. And that's where the next micro center is. There's one in Fort Worth, and there's one in Kansas City. And there's one in... What city is this? Houston. So Fort Worth, Houston, and Oklahoma City, and Kansas City. Arkansas, Mississippi, Louisiana, just fuck you guys, you don't get one. There's a couple, there's 2 of them in Nashville. Looks like one in whatever the hell this city is, it won't tell me. St. Louis. Oh, I can show you. Duh. Where's it at? Okay. So here we are. So you got one out here in near Irvine, Denver, up here in whatever that is. Minnesota has one. And then you don't start getting dense until you get northeast up here. Even when I lived in Philadelphia, I never really went to Micro Center because the nearest Micro Center was the west side of Philadelphia. Although now I see there's a couple in Jersey. Although it's way up north. It's New York. It's not Jersey. So New York, there's one in Philadelphia, but it was all the way out here. It's like a freaking hour and 20-minute ride. I was like, screw that. But yeah, there's Micro Center. I should probably try to grab one when I'm up in Denver, but I ain't got the $100. Ain't got the money. Is that where I think it is? That's right around the corner from where David lives. David, my friend, lives right there, so I'll be right around the corner from the Micro Center. Yeah, I don't. I can't justify spending $100 on that. But yeah, Ender 3, I mean, you can't beat that. $99, and it's the Pro. You can't beat that with a 10-foot stick. Now, the mag sheet that it comes with is garbage. You're going to want to replace that with a steel plate. Because it's the flexible magnetic sheet, and it's garbage. What? Are you still selling pot? No, I don't sell pot. Exactly. Just use an email or phone number they don't have. You can go on Google Voice and get a phone number for free. So unless they recognize you, it's a $99 Ender 3. It's pretty tough to argue with that. I just realized I need to design a stand for these rockets. So a way for them to stand up. And I just realized that I could design one of these with sockets to put legs in it. And then just screw it in the bottom rocket and the rocket will stand up. I just realized that would not even be that difficult. Ooh, I gotta do that. 3 angle plugs, shove 3 dowel rods into it, and boom. Instant stable platform for the rocket. I'm gonna have to do that. Wouldn't take much plastic either. I mean, what's that? 10 grams?
What are you two up to?
Up to no good, of course. Come on, Noel. Shove them out. Push them right out of there. Bite him on the back of the neck. Exert dominance like he does to you.
Look at the way he's looking at him like, yeah.
Because he wants to get in there and he can't.
Mommy can help him, but Mommy doesn't want to get involved. You know what I mean?
Yeah. So here's how I do that. Curious. So here's that one. So as you can see, this is the bottom of the rocket that actually should look like that. And then this piece sits on top of that, and then this piece sits on top of that. And so obviously I can't print this way because you can't print a ring in midair. But the reason I broke these where I did was so that the 2 rings can sit on the build platform. The problem is this ring keeps pulling up. I should have made it a little smaller so that I wouldn't be going all the way to the edge of the build platform, because I think it's the temperature delta between the edge and the center that's causing it, because this piece here is not pulling up. So I think either which way I'm going to have to shrink this ring enough to allow me to put a brim around the whole thing. Because right now I can't put a brim around it. It would go off the print bed. Although I wonder if I technically have more space than it claims. Like, can I go to 305? I don't know. Because I only need 6 extra millimeters. 3 on each side. So I'm going to do at least a 10 loop brim. And that's 4 millimeters. So I'd probably have to do a 9 loop. No. Yeah. It'd have to be... So 4 would be 1.6, so 4.2 millimeters would be 8 loops. So I would need I need to make that 8.4 millimeters smaller in order to allow me to put 8 loops of brim around it. Maybe a brim combined with the ears on the inside. Maybe that'll be enough to hold it down. I'm surprised that PLA warped that much. I mean, it's a lot of warping. Let's hide one of these, then delete the extras. Bring it back. There we go. But same deal. So you have this 2-path wide tab sticking out, and then the fin has a slot, and there's play in that slot to allow me to center it. And so I just cover this with glue and slap it on there. And then I can make the Mars probe. But that came out pretty cool. I'm looking forward to printing that. I still want to do something with the Scorpius too. I really like the idea of the Scorpius. I want to print that. That is on the next page. I also want to upscale the Disruptor. The Disruptor's pretty cool looking. Here it is. But this one here is really cool. It's just a neat design. Simple but neat. But that actually sits like that, and then there's you put wooden rods between the two to connect them. I did take some artistic license. So the original one has a single fin here. I used 2 to make this more rigid. So by using 2, this is all stiffer. But that's a cool model design. Will it print on the Ender 5? No. I'd have to downscale it to print on the Ender 5. Well, wait a minute. Maybe. No, because the parts are 400 millimeters tall. So I'd have to rework it to allow it to be printed on the smaller printer. Let me show you. Let's see here. This is George Racker. He's one of the guys from Rocketry, so we fly rockets together. I got it all fabbed up, and it is now printing. There it is. It's printing out the Starlight now. I got it set up for both 1/4-inch launch lugs and 1010 rails. So there is actually enough space in here for a 1010 rail. I actually have I deleted it, right? But I have a model of the 1010 rail. So the way I made that work, George, was I just don't print the fin. I only print this portion of the fin. And then there's a socket, a channel in here. And then you print the fin separately. And then that fin fits inside that channel. So these will fit on your printer diameter-wise, but not length-wise. So I would have to split both of these parts into 2 more pieces. So instead of printing this, and 4 of these, you'd have to print 2 pieces for this, 2 pieces for this, 2 pieces for this, and then these. This should fit. It's 285 millimeters, and I believe you can print 330 millimeters on the Ender 5. Let's find out. So 220 times 220 times 2 equals 96,800 square root. Yes, 311. So you could print 311 millimeters long if it's a thin object and you print it diagonally. This you'd use a 334. So a 334 is a printer that is 300 by 300 by 400. So that's a CR10. So any 334 printer would work. Doesn't have to be an expensive one. 300 by 300 printer. 3D. It's too bad the Ender 3 Max wouldn't work, because that's a nice cheap printer, but it's a 333, not a 334. And I designed this around 334. So here you go. Here's the longer LK5 Pro, $295. So $300, and you have a I'll add that to the list. So that's actually a really good deal. It's currently on sale. Excuse me. Don't friggin' argue with me. Let's see, 3D printers. That's actually a decent machine, and that's only $295, which is really cheap for a 335 or 334. Let's see, that's 500, that's 600. 8 plus will do it, but I wouldn't buy that. Wow, here's one for 200. Holy crap. I have no idea if this is any good at all. And I think this is the one that I have in the box still. The Monoprice MP10. I think that's the one I have in the box. And that is, what's the build height? 300 by 300 by what? Oh, you got the Anchorman MM5? Nice, dude. Yeah, 400. Wow. This Monoprice MP10 would do it, and it's only $179 freaking dollars. Jesus. That's really cheap for a printer that big. I don't know if there's any issues with this printer or not. Is it a direct drive? No, it's got to be a Bowden. I like the open architecture on the front, though. I like that open architecture. And then here's the Malian MA10. This looks like a copy of the MP10. Wow. I have no idea what the quality is of this. Very cheap for the size. Especially the Monoprice. And it looks like it's using regular parts. That's the big thing. If it was proprietary, I wouldn't touch it. But it looks like it's using common parts. Wow, it's even got a swappable hot end. And it comes with a flex plate. Wow. Maybe I better dig out that printer I have in the closet. I mean, that's really cheap. This is the WeDo ME40. That's actually the printer I'm printing on right now. That also comes with a flex plate, although I put a different sticker on it. Jesus. Well, that's awfully nice. Okay, the $600 one is the one that has the big build volume. What is that, a 443 or 444? Oh, 45, 40, 40. Interesting. So it's a 450 by 40, 400 by 400 build volume. That's interesting. The Cobra is Ender 3 sized. Yeah, 220 by 250. And the Neo is also 220 by 250. Yeah, I bet. Here's a Sunlu S8 for 219. Holy crap. And that's a 310 by 310 by 400. Wow. I'm really impressed by how cheap that is. I mean, that's incredibly cheap. The Sunlu and the Monoprice is probably the two I'd look at. I wish I had a few of these. I do have one. I got to get it set up again. I mean, it's a pain in the ass. It's 12 volts, so it's annoying as hell. Wait a minute. It has a CR Touch? Is this an updated version? Can't be. I don't think they would update it. Too small a build volume and too high a price. I can never afford one. Yeah, but did they update it to 24 volt? Or is it still 12 volts? Hello, Yamaha. I'm going to assume it's still 12 volts. Yeah, well, this is $200 and it's way bigger than a bamboo. I mean, the cheapest bamboo is $700. It's only got a 256 cube build volume. And it's full of proprietary parts. Good luck fixing it when it breaks. I'm kind of concerned about that, especially since the response from the manufacturer has not been, well, it's kind of weird, okay? On the one hand, they're willing to replace the printer for the guy, but they won't just send him the part he needs. I don't know. Polymaker Polywood is not wood. If I remember correctly, I could be wrong, but if I remember correctly, Polymaker Polywood is simulated wood. It's made to look like wood, but it's actually just PLA, which means you should print fine. You're the one, they lost the box and they wanted to charge you for it, and then they said they're willing to send the printer. That was you? You know, I don't like the idea that they won't send you parts. Why not just send the bad part? Why send a whole new printer? Now, while the printer's under warranty, that's great, I guess. It shouldn't. Hang on, let me find out. "3D for Joe, how are you?" I haven't heard nothing about the M5. It kind of got overshadowed by the bamboo. Okay. Yeah, it's a wood mimic without actually using wood powder. So you should be fine printing with that. That should not cause you any nozzle problems. Wood filament should not wear a nozzle. Under normal conditions, wood is not capable of wearing down a nozzle. Yeah, I definitely would like to hear from you about that. Oh, okay. Well, I guess that makes sense. The problem though is what happens if somebody with an older model wants to repair their printer out of warranty? Are they going to send them a new printer, or are they going to make them buy a whole new printer? Yeah, that should be just fine with a 0.4 millimeter nozzle, Mike. You should have no problems. Clogging is the primary issue with wood filaments, which this is not wood, so you should be fine. It should have zero clogging issues. Wood-related clogging issues. They'll replace it, even out of warranty? Okay, well, if they're willing to stand behind it, then I guess it's okay. But my big concern is you know, these machines are not disposable. They're not supposed to be. They're machines. And I want to make sure that, you know, you'll be able to repair the thing a year from now, 2 years from now when it has no warranty. And that's why I don't like proprietary. Now, some aspects of the machine have to be proprietary. Okay, so if they're willing to stand behind those early adopters, then I'm okay with that. Um, that's what I mean. Parts should be cheap for them. It shouldn't be expensive at all. The Now some aspects of the printer are necessarily proprietary because they're doing things that normal printers don't do. Um, you know, like the LiDAR and the vibration system and stuff like that. You know, that's all brand new. You know, they're basically first movers on that kind of thing. So I get it to a point. I just hope I hope people don't get burned, because the performance we're seeing is incredible. It really does look like an amazing piece of machinery. I worry when it's proprietary. Now they just need to bring that price down to something us mere mortals can afford. Yeah, remember, the reason people like me don't buy a Prusa is because Prusas are expensive. So comparing it to a Prusa doesn't really work. Plus, the bamboo has a much bigger build volume than a Prusa. Well, Chinese company. Customer service is always a problem, especially when they're charging first world prices. You know, $700 and $1,500 for a printer. You expect some service with that. Oh yeah, definitely. And it's got a much bigger build volume, 256 cubed, which is what's that? 50% more build volume than a Prusa. Although the new XL looks pretty slick. Well, hired a company, and does that company have any teeth? Meaning, do they have any power? Do they have any authority? As long as they do, then yeah, okay. Wish they'd have sent me one, but you know, nothing you can do about that. So far, people are getting some. You see that one guy who got like 4 of them, and he built that entire droid in a couple days. How has the layer bonding been good at the higher speed printing? Have you tried to do any thin wall prints? Like, one of the reasons that I print slower, even though I could print this, I can make this part at twice the speed. But the freeway is closed going into Edgewood. There's usually notice of that. If there's an accident. No, what I mean is usually the reason I slow down is to get a better melt layer to layer, to make sure that, because my rockets aren't going to just sit on a shelf. Oh, flip semi. Well, that's what I mean. Have you tried to print something like this? Have you tried to print something thin wall lightweight? Because the way that I do this is there's actually the ribs are no big deal, but one of these ribs goes all the way through. And if I don't get proper fusion, this will blow apart when the ejection charge fires. And I always worry that if I go too fast, I'm going to get inadequate layer bonding, and then it's going to, you know, blow apart. Especially that seam, because you know, one layer, it's an entire layer on top of another layer, so you're going to get a pretty good melt. But that seam, it does the inside, and then it does all the ribs and all the outside, and then it goes outside. So that first line has had a long time to cool down before it gets passed again by the nozzle, and so it's not going to remelt as much. And on some people's printers, I've had the seams burst open at ejection charge. Because being able to do parts fast would be nice. If your CR10, if it's not software, like if the software hasn't changed, like you haven't written new firmware for it or something like that, it could be your heater's dying. You have an intermittent connection with the heater, or the heater cartridge itself is dying. I have had that happen where the printer just would not hold temperature. And I ended up having to, it wasn't the thermistor that was the problem, it was the heater cartridge itself unable to maintain the heat. Good news is they're dirt cheap. Just make sure you get 12 volt or 24 volt depending on what your printer is. Huh, no one's mentioning CR10S. That's going to be 12 volts, I believe. I believe the CR10S is 12 volts. So you need to make sure you get a 12 volt heater. Because Amazon is a moron, and you'll do a search for 12 volt and it'll show you 24 volt. Been there, done that. The wiring on the CR10S is monolithic all the way from the box to the heater cartridge. So if you have a wiring issue, you have to replace the heater cartridge. Yeah, I don't see no mention of the traffic. I'm surprised. Well, but I'm just letting him know can you splice that wire? Like that funky insulated red wire, can you splice that? I wasn't sure how serviceable that was, because that would suck to have to rerun that entire wire. It's one of the things I like about the newer printers with the breakout boards. The breakout boards are nice. I wonder if you could update the old printer to use a breakout board, because there's, as far as I know, there's no smarts inside that board. It's just a breakout board with plugs on it. I would love to get a Voron 0.1. I would love to build one of those, but again, they're pricey. Building a Voron is not cheap. It had been stood for 6 months. I don't understand. I know stood is probably a typo, but I can't figure out what you meant. Steady? It has been steady or stock? Not used, okay. Yep, that's right. Oh man, I remember I had to completely rewire one of those because the damn blind nut on the inside came loose, the nut holding the socket, the aviation plug on the box. And so I'm turning the plug on the outside without realizing that I'm twisting the entire plug around and tearing all the wires out. Oh, that sucked. Ah, now I know to check for that. JSTSM. Those are sufficient for the heater cartridge? They can handle 40 or 50 watts? Um, it's awesome. I didn't know they can handle that much power. Cool. For some reason, I thought you had to use something beefier. I wonder if the RC connections would work. JST RC. Because I have a lot of those. Would these work? Oh, I know. But these are also really thin wires. Like, would these work? Looks like the same wire and same plugs, just a different socket. Because I have a lot. I like how slim they are, and I have a lot of these. I got a couple hundred of these. These are my favorite plugs just because they're so simple. I think I have one right here. Yep. Yeah, these. Those plugs there. Those are my favorites. The wire is the same thickness, so. But cool. I didn't know that. Just having plugs to be able to swap the hot end. Especially on the older printers because there's not that many plugs. I mean, you only have 4 wires. 4 sets of wires. You have the heater, the thermistor, and the 2 fans. So you only have 8 wires. You only have 4 sets of wires, so you'd only need 4 of these plugs to make the whole hot end swappable. Especially for printers like the Chiron and the CR10S5, CR10S4, the big printers where you might have, a legit need to swap nozzles. Send me a link to how you do that. Because if there's a pre-made way to do it already, I'll just do that. Because I like the idea of, disconnect the Bowden tube, swap 4 wires, I can change the hot end. It'd just be nice, today I want a 0.4 millimeter to make a lightweight rocket. Tomorrow I want a 1.2 millimeter nozzle to do my, big vase prints. Because sometimes you need the big print volume, you want a big nozzle, 1 millimeter, 1.2 millimeter. But then there are times where you want the 0.4 millimeter nozzle to keep the model lightweight, but you want to print big. Like there are some fin cans that will not fit on a 334. That's why I have to, for example, I scaled this up. Those fins are too large. They would extend too far out. So I have to print the fins as a separate piece. Yeah. No, it's 4 wires. There's 2 wires for the thermistor. There's 4 connections. 8 wires total. Each connection's 2 wires. So you need 4 plugs, 8 wires. Because you got 2 for the cooling fan, 2 for the parts fan, 2 for the thermistor, and 2 for the heater. On the older hot ends, it's that simple. It's just 8 wires. Yeah, they are nice. Being able to swap just the nozzle quickly would be nice. Although, if I went to an all-metal hot end, that would also solve that problem, wouldn't it? Since there's no Bowden tube. Yeah, 4 connections, 8 wires. In fact, the fans, I would probably unify into a 4-pin connector. And then I would probably do the heater cartridge in a different kind of connector, just so that you can't accidentally plug thermistor and heater together. Yeah, it'd probably be smart to have different plugs for that. So I can get it down to 3 connections. If I use a 4-pin wire for the fans, and then 2 separate 2-pin wires for the heater and thermistor, I could get it down to 3 connections plus the Bowden. Yeah, my favorite's the 1.2 millimeters, just because it's triple the 1.4 millimeter. You can get a 1.4 millimeter nozzle from a CHT nozzle, and it actually does work pretty good, but that's really pushing the limits of stock hot ends. you got to really slow down, especially if you're doing thicker layer heights. You got to really slow down to be able to melt that much plastic. But 1.2 seems to be 1 and 1.2 seem to be a really nice balance. I could do 0.4 millimeter thick layers at 30 millimeters per second, which is the same thing as you doing, 180 millimeters per second. Well, you can't crank the heat though. There's a limit. Like when I was running a stainless steel 1.5 millimeter nozzle, don't buy stainless steel nozzles. They suck. Oh God, they're garbage. But anyway, I was pushing 250 degrees for PLA, and it still wasn't enough. And I couldn't go any hotter. I was cooking off the PLA as it was going through the nozzle. The outside of the PLA was cooking off while the inside was still not fully melted. So there's a limit. Now, if you went like Volcano, where you had a longer melt zone, also these new CHT nozzles, the knockoffs especially, they work very well. They have a copper insert, so they actually work even better than the CHT nozzles. They're actually, these knockoff nozzles, the CHT knockoffs, are on par with a regular Volcano nozzle. Yeah, it's incredible. And then if you make them, you can actually get them in Volcano versions, and then it's even better. It's like but then you need to do thermistor, because your stock doesn't the stock thermistor not go to 300? No, the problem is though, you're cooking off the filament. You're burning the filament as it goes through the hot end at that temperature. I reached a thermal limit where, I was either not melting it enough or I was burning the filament and it was becoming brittle when it printed. So I'd have to go with a test set like that. I'd probably use the Viper because it's got a Volcano. Oh, so a stock thermistor will read to 300 accurately? Like you could safely go 300 with a stock thermistor? I thought that was the whole point, that you had to change the thermistor. And not have a PTFE tube, of course, but that's another issue. That's interesting. Because I'd like to print ABS hotter. I'd like to print ABS at 260, 270. It prints a lot better at higher temperature. ABS is a pig for heat. It'll take as much as you can give it. Yeah, well, then obviously you don't use PLA. Oh, but for what I was printing, I wanted to use PLA. Because PLA is cheap and I have 700 kilograms of it. Well, probably 600 now. But, cool. I might have to try that. Because I think I think that new hot end I put on the Chiron is all metal. I think the PTFE tube doesn't go to the hot zone. So I may mod that to do that. I thought I had to replace more parts. Oh, this is looking good. I don't see any. Oh, God. I don't see any issues at the socket for the fin. It looks clean. And it still has not warped or pulled from the bed. And so it's probably not going to at this point. It's 200 millimeters tall. But this is looking good. I think you're going to like the Starlight, George. It's looking really nice. I'll probably have to make a 60 millimeter version. This is the 80 millimeter version, 3-inch. But if I go down to like 2 1/4 inch, 2.5 inch, something like that, that should be printable on an Ender 5. Wait a minute. If you mod the firmware to go to 300, it imposes a 15-degree limit. Paintable? Yes. PLA is totally paintable. Where would the 15-degree limit come from? can't you just increase that limit to 315 degrees so that you can reach 300? Because I want to print like polycarbonate. You know, that's going to need the full 300. So that's like a firmware safety limit. I hear birds. I gotta get the hummingbird feeders out. It's almost hummingbird time. I got a couple of them up there. Like, there's a hummingbird feeder right there. Right there. That's a hummingbird feeder right there. And I think this box is a hummingbird feeder too. Oh, absolutely. I want to get one of those slice engineering hot ends. I think this was the most annoying print I've done in a very, very long time. I was using 4 different printers, multiple tries each printer to try to get this goddamn thing to print. Always, at some point, one of those links would disconnect from the bed, and that's it. You're done. Once a link disconnects, you're screwed, and there's 40 of them. What a pain in the ass. But finally, one of them stuck, and I got a complete print. And so I made the print-in-place cat toy. And he seems to like it. Although I think next time I'll do this a little bit thinner, so it's a little bit lighter. Because, you know, I'm worried that that's heavy enough that I could hurt him if I flick it the wrong way and it hits him. Maybe not. Maybe I'm over concerned about it. But yeah, that printed nice. Hi, baby. You want to play with the fish? You want to play with the fish? Huh? You haven't played with the new fishy toy yet. Huh? Yeah? Yeah? You just want some petting? Huh, baby? Yeah. You're a good boy. You know, my viewers haven't seen you in a while. Yeah. They haven't seen little Nosy in a while. Yeah. He's so soft. He is a very, very soft kitty. Yes, he is. Really? 300C is enough to affect the aluminum heat block? Is that a melting issue or an expansion issue? And where do you get copper heat blocks? Because copper's good. I like copper. It's got like the only thing better than copper would be that PCD from US Metals. Well, that long. Every now and then I'll have Michelle just take a pair of scissors and snip off the end. No haircuts. That's the reason for it. No haircuts. Saves me $120 a year. Probably more now. I wonder what a haircut costs lately. That's not really a monetary thing so much as a pet peeve. Yeah, because my hair grows really fast until it gets to a certain length, and then it's just like it puts on the brakes and just stops. And I damn near pull as much hair out each day as I brush it. You can see I create these nice big hair balls that I pull out of my brush. So Nice big ball of hair. That's a little one. But yeah, I got tired of paying $30 for a haircut. Every goddamn 3 months I'd have to get a haircut. I think it looks better when I have a haircut, but it's just, cash, man. Ponytail means no haircuts. Ew! So you can just cough it up and puke it up on my floor somewhere else? Yeah. I have enough of a problem stopping them from eating all the filament strands. The cats love eating the goddamn filament strands. Not around here. It's $30 for a haircut around here, plus tip. So you're looking at like $28 to $35 for a haircut. Back in Pennsylvania, you could at least drive to the beauty school in Philadelphia and you get a haircut for like $15. Yeah, but the cheapest haircut I found around here is $30. I haven't checked in Albuquerque. But even if you get it for $20 in Albuquerque, you're going to spend $10 in gas driving to Albuquerque and back. It's a 40-mile round trip. So, yeah, I'd rather just not have haircuts. I got a big pair of scissors. Every now and then I just take the end of it and go... It just needs to be long enough to tie up. So I actually have to figure out how I'm going to plan for next winter. Because we might not get so lucky with a mild winter next year. And I also can't afford $168 extra a month to run that one heater. Michelle's room's no problem. The little 500-watt heater is enough to keep her room warm. Although that was during this mild winter. I have no idea what's going to happen if the winter gets colder. And, so I got to prepare. Because, like, for example, to use the fueled heater the entire winter, I've got 2 heaters. I've got 4 wicks. And I also have a diesel forced air heater. So I have triple redundancy there. How much fuel will I need? Assuming I can get by on 2 gallons a day, which should be possible if I keep it on low. You're looking at 30 or 60 gallons a month. That means I would need at least 240 gallons of fuel. That's a lot of money. I mean, that's $1,000. I mean, Jesus. It costs the same as running the electric heater. Damn, that's a lot of money. What I need to do is get some solar panels. Damn it. If I could just get some solar panels. I need about 3 kilowatts of solar panels. If I had 3 kilowatts of solar panels, I could run the electric heater during the day on solar power, and then at night run the fuel heater. And that would probably be enough. I would be in even worse shape in Pennsylvania, where it costs substantially more with a substantially larger house. One of the benefits of living here is everything is cheaper in that regard because, it's a smaller house, so it takes less heat. I would need, $500 a month in fuel in Pennsylvania. Here I only need $240 a month in fuel. Kerosene would be better, but they charge so much money for kerosene. Have you seen what kerosene costs lately? $10 a gallon. What? Who can afford $20 a day for heat in their house? That's lunacy. Yeah, but you don't actually have that power. That's grid tie. So that's power being sold back to the utility. They're out here they're very hostile towards solar. we have a co-op for electric. And so even if I had 100% solar, I would still be paying $40 a month to the electric company for their minimum taxes and fees, even if I had no power. If I went outside and turned off the main breaker, so I shut off the power to this house, it's still going to cost me about $35-$38 a month just to have that connection available. So no matter how much solar you create, you can't erase that. You're paying that much per month no matter what. On top of that, we're not allowed to bank solar. So, for example, your solar system is probably designed to provide you with enough power on a summer day. And then the excess power you create, you bank that for winter. We can't bank power. We can only offset power used the same month, which means I would have to have a solar system that was large enough for the worst possible day of the year. Solar getting a meter doesn't matter. That's irrelevant. The problem is, unless you get in early, like while they still have net metering and stuff like that, solar is a dead end. It eventually will not work. And the reason for that is pretty simple, and it's actually logical. It actually makes sense. I don't begrudge them of that. What I do begrudge them is not letting people bank power. The problem is, no matter how many solar panels you have, when it's raining, cloudy, snowing, or nighttime, you're not making power. And so you still need that grid to provide you with that power. So somebody has to pay them to run the grid. And as more and more people use solar panels to offset their electric bill, fewer and fewer people are going to be paying the grid. No, not futures. Literally, somebody has to put fuel in that power plant and run that power plant to give you power. The only way solar can work is with batteries, because then you just disconnect from the grid altogether, and now they have their own problem to deal with, and you simply store your excess power in a battery bank, and now solar works for everybody. The problem is right now, batteries are expensive. They're actually not. Batteries are actually dirt cheap, but the amount of them that you need makes it very expensive. I would need a $25,000 battery pack to run this house. The problem is that doesn't make any sense. I mean, even if I average $200 a month electric, which I don't, my summer bill is a lot less than that. But even if I average $200 a day, or a month, that's $2,400 a year times 10. So the batteries alone, the cost of the batteries, I could just pay the electric company for the next 10 years. And now you still have to add the solar panels, all the wiring, the inverters, the charge controllers. Yeah, sounds about right. Okay. So what did your solar install cost you? And unless you have cash, you don't get the rebates anymore. The rebates are fiction. There is no rebates unless you have cash. If you have cash, then you get rebates. But if you don't have cash or really, really, really good deal with your bank, you don't get the rebates. The 30% federal rebate for solar, because the banks are charging you 50% interest. So they're taking all the rebates from you with interest. I laughed at the guy, and he knew what I did as soon as I did it. He's like, I guess he's had that conversation. I was figuring a $16,000 to $18,000 solar system for my house because I need 9 kilowatts per day. I need a 9 kilowatt solar array. Yeah, so you paid twice what the solar should have cost. That solar system probably should have cost you, 20 grand, 18 grand, but with interest, you paid 30. Now, when I say interest, I'm not talking about the interest on the loan. They're double charging interest. So for me to get a solar system here, it's about a $16,000 solar system if I had cash. So if I had cash in my hand, the cost is $16,000. To get a 30-year load for that same solar system, $54,000. I was like, that doesn't make any sense. I was like, how does that work? That's like 350% interest. What? Or 300% interest rate. And that's because the bank charges a $25,000 fee up front. Basically, $25,000 in interest up front. They're literally stealing the 30% federal and state rebates. It's literally racketeering. And then you're going to pay 30 years of compounded interest on the $16,000 solar system and the $25,000 upfront fee. Then you're paying 30 years interest on that. That's why your system was $30,000, not $20,000. No, that can't work. Because if everybody has solar panels on their roof, the electric company goes bankrupt. Or they start doing what our electric company did. They charge minimum monthly fees, and you can't bank your stored power. That's what they have to do. That's not them. That's actually not them being corrupt bastards. That's logical. You're producing time of use power, but then you're not paying for your on-peak power that you use at night because you created excess off-peak power during the day. That's not sustainable. That can't work. That's a net negative interaction that has to fail. The only way that might work is if we had a nationwide, nationalized power grid where the power companies were not owned by private companies, where they were owned by the government as a public utility, and nobody paid for electricity. It was part of your taxes. Then that could work, because then the more solar panels you add, the less load there is on the grid as a total. Well, like I said, you found a way to make that work. You essentially had cash. I don't have that option. So I pay a $25,000 penalty up front, and then I pay interest on that $25,000 penalty for 30 years. And I was like, wait a minute. And he told me the monthly payment, and I was like, and I did the math. I was like, dude, that's like 300% interest. No, I'm in New Mexico. Our electric company is a co-op. It's not a regular utility. It's a co-op. And so they're smaller, and they can't afford to absorb solar losses. And they don't have enough customers where they need that much solar to offset. So it's just bad circumstance. There's nothing I can do about it. You see, your power is already pretty green. Hydro and wind. That's nice. And so not only do you have affordable power, but you also have a relatively low population. You live in Oregon. So that's a double win for you. I was surprised you do that well with the solar, considering your elevation, your not elevation, your latitude. How much further north you are. That's pretty impressive. 100 kilowatt hours a day. Jesus. Good job. So the only way I could go solar is if I had cash to pay up front. Yeah, yours is before they started slurping up all the rebates. And also, it depends on the bank. The guy I was talking to said that some credit unions will give you a loan for cash, to allow you to install a solar system. So, for example, if my credit union would give me a $16,000 loan at, say, 2% interest, well, you didn't pay any interest, but you did. You paid $21,000. That's $5,000 or $6,000 more than that system should have cost you. So now you benefited. So they basically lump the interest in with your price, unless that's bigger than I'm thinking. No, that's about the same size I was looking at. Yeah, that should have cost you $5K less. Because I'm looking at about $16,000 for a 100 kilowatt system. 9 kilowatts times 10 hours, that's 90 kilowatt hours a day. It's about 100 kilowatt hours. Small difference at that point. Now, if you can secure your own financing, then that works a lot better. But at least the companies that have all called me back, it's crazy. The banks are just charging incredible fees. Maybe there's that big of a difference from 2019 to now. I don't know. Huh. I was thinking about a water storage heating system, but oh my God, the amount of power. Jesus. Millions of kilowatt hours. Water can hold a lot of energy, but it takes a lot of energy to put that energy into the water. Well, 3% interest over 30 years is not 3% interest. Okay? 3% interest over 30 years is more like, what, 60% interest? All right, well, we can do the math. I can show you. Hang on, that's actually pretty easy. 3% is better than most, but you're still paying a lot more than you think. Well, yeah, 15 years is going to make a huge difference. So let's say $16,000 solar system, interest rate 3%. Let's do the 30-year first. Yeah, you're looking at $67 a month. 67 times 12 times 30, $24,120 divided by, I believe 160 is my factor. That's 150% interest. So you'd be paying 150% interest rate. No, that's wrong. 50% interest rate. Your interest rate would be 50% because 100 is the principal. But here's what they were doing with mine. They were saying, okay, $16,000 system plus the $25,000 lump sum upfront payment the bank wanted for a total of $41,000. And now when you amortize that over 30 years at like a 2% interest rate or something like that, whatever it was, it came to $54,000. And so if you figure that out, 54 divided by 160, that's a 237.5% interest rate. It's because of that lump sum they added on at the beginning. So not only is that essentially interest, you're just paying it up front, but now you're paying 30 years of compounded interest on top of that. So it came out to, and that's about right. It was about 240% interest they wanted to charge me. He's like, no, it's 2%. I was like, no, the $25,000 is interest. That fee is interest. And now you're paying 2% compound interest on top of that. It was crazy. Maybe they were just scammers, the whole lot of them. I don't know, but it was, the numbers they were giving me were absolutely bonkers insane. And then on top of that, he says, I was like, well, what happens if that system fails? Now I'm stuck paying a loan on a solar system and paying an electric bill. He's like, well, it's got a 25-year warranty. And that's like, if your company exists for 25 years. If your company goes tits up in 5 years, I'm screwed. You know what I mean? And I'm pretty sure there's no equivalent to gap insurance for something like that. That's nice. 0 interest plus the rebates. Was that a government program or a private bank program? How many pieces? The Aquarius? You talking about the Aquarius? Or are you talking about the Mars probe that I'm working on? The yellow Aquarius is one, two, three. So this 3 parts. This whole thing is 1 part. This is 1 part. This is 1 part. So it's 3 parts. The nose cone is 2 parts. I could make it 1 part, but I prefer modular nose cone. So this piece here can unscrew. But you could theoretically do that as 1 part. But I prefer 2. So that's a 2-piece nose cone. And then, of course, you still also have the motor mount. So this is the 24mm motor mount. You would glue a piece of tube to this. So you would take I guess that's about the right length. You would take a piece of that, and that would get epoxied to that. And then once that's epoxied together, this whole thing would thread into here, like that. And there's your motor mount. And that would be the top of the tube inside there. There's holes in the coupler for attaching a shock cord. There's holes in the motor mount for attaching a shock cord. So this would all integrate. You could print this on your Ender 5, no problem. And and also you have 18 of these. You have to print 18 of these. These are the little caps to cover up the top of the tubes because they're not supposed to be open. The bottom is just a bottom layer, so you don't need a cap for that side. You just need the caps for the top side. So yeah, the 4 primary parts, 3 body sections plus the nose, and then you also have the what I call the smalls. You have the caps, the coupler, that. Yeah, that was the issue. Well, there's not, unless you have a really high electric bill like George did. You know, when your electric bill's $400 or $500 a month, solar makes sense a whole lot faster. But when your electric bill is like mine, my non-winter electric bill is under $150 a month. I've had electric bills as low as 110. At that price, solar doesn't make a lot of sense. I want to do solar because I want to, not because I need to. For example, I only need a 1 kilowatt solar panel to do air conditioning. A 500 watt air conditioner is sufficient for 90% of my cooling needs. And if I were to hook that up to a 1 kilowatt solar panel with a small battery as a buffer, that would work. Wind is very, very expensive at the house level, at the residential level, because the little turbines you can buy on Amazon, they don't really do shit. They really don't make all that much power. To get house level power from wind is very expensive. Solar is your best. It's maintenance free. There's nothing to break. There's, except for hosing it off once a month or once every other month. You don't have to do any maintenance to it. It'll last for 30 or 40 years without a problem. It'll last even longer than that. It's just the performance degrades over time. So you just oversize your system to compensate for that. The big problem is the batteries. Batteries are expensive. What I wish they could do, I know it's actually technically difficult. Mixing AC current is hard. Phasing AC current to work together is actually pretty difficult. Wind would have been too noisy. Tell your neighbors when they pay your tax bill and your mortgage, then they can have a say. That's what I would tell them. But oh, by the way, the Aquarius nose cone looks pretty good on the disruptor body too. I just stuck it on there because why not? That actually looks kind of good. I kind of like that. I like this disruptor body. It's pretty nice. What are you gonna do? But I wish there was a way to hook up solar panels in a local grid tie scenario. So instead of selling my electricity back to the grid, just let my house use the power. And then it will just, so it'll draw less. Yeah, it does kind of look like the Blue Origin. The very nature of rockets is phallic, so you can't do much to get around that. Yeah, but that bulging nose kind of screamed it, didn't it? You don't need a license to buy ammonia. Well, the problem is 2 Tesla batteries are $36,000 plus tax. If you gave me the batteries for free and said just pay the tax, I couldn't afford it. Because what would the taxes be on that? 3600 times 0.08125. The taxes alone, just the sales tax alone, would be $3,000. About my yearly income. So if you said, hey, here's 2 batteries for free, just pay the taxes, I couldn't do it. But it would be nice if I could. That's cool. A lot of people don't realize that when the batteries are used up in an electric car, the batteries aren't bad. The batteries are still perfectly good. They just don't have the same capacity. They just have a lower capacity. In a car, that's a problem. In a house, that's not a problem because you have space to put more batteries in a house. If you need twice the space, so what? You just use twice the space. In a car, you can't do that. Not as easily. But I wish there was a way to an affordable way so that I can set up any random assortment of solar panels and feed that power into a gadget. And that gadget would power my house using both the solar energy and the grid power, where it would prioritize solar. So if I'm generating, a kilowatt of solar power and I'm drawing 1.5 kilowatts, then it should only be drawing half a kilowatt from the grid. Crosley refrigerator, I'll check that out. So there are battery backup boxes that will do that, like my big 1.5 kilowatt battery box that I have there. It will do that. So if I plug solar panels into it and I plug the AC charger into it, it'll prioritize the solar power. So it'll use the solar power first and then get whatever leftover it needs from the AC power. What we need is a house level version of that that's affordable. And this way, I can just, I found another $30 used solar panel, plug it in, and I'm making that much more power. Allow an ad hoc arrangement. Basically our own version of grid tie. Don't feed the power back to the grid so you don't have to worry about that. Just have it so that I use the power locally. And something else that would work out nice is if manufacturers started putting DC connections on their appliances. So allow appliances to run on both AC and DC, and have them smart enough to prioritize using the DC power and only take AC power when there's not enough DC power. And this way people could set up, a 12, 24, 48 volt grid in their house, a separate grid in the entire house with a separate, panel and everything. This way it would have no connection to the utility grid, and this way there'd be no issues with feedback. And DC only because it's a lot easier to get DC out of solar panels because that's what they make. Solar panels make DC. They don't make AC. In order to get AC out of a solar panel, you have to put a inverter on it to convert the DC to AC. And now you have another problem where you can have feedback from one grid to the other because they're both AC and they're both on the same connection, but also phasing. it's difficult. There's a reason those generators that you can hook two together, there's a reason there's a cable connecting the two generators together. That's so they can synchronize the phases. That's actually pretty hard to do. I actually have a solar powered light that does exactly that. Very expensive, stupidly expensive. I got it for free. It's the only reason I have it. But it's a solar light that you have a solar panel connected to the light, and it also has an AC wall plug. Yet it will actually prioritize using the solar panel. So during the day, when you flip the light switch on, it's going to use solar power. And then as the solar power goes down, it draws more and more power from the AC adapter. That works largely because it's AC/DC. So it's converting that power brick is converted to DC. So you have two DC inputs, essentially. I wish more products came with that, with two plugs on them, an AC plug and a DC plug. So that if you have, a 12 volt or 24 volt grid, you can plug it into that. And if there's enough power there, it'll use that. And if there's not enough power, then it'll draw from the AC side. It'd be nice to see that more automated. I can't build one myself because I don't even know where to begin. I mean, that's going to require software and electronics. That's not going to be simple relays and switches. You're going to have a CPU that's going to have to understand, okay, I've got this power source and that power source, so I'm going to power off this one, and I'm only going to draw from this one when I need it, and I'm going to have to mix that power together in such a way so the device doesn't get pissed off. So I know it's not that easy, but it'd be nice to see, because then people could start putting up ad hoc solar arrays. Instead of putting up a 21,100 kilowatt system, I could put up a $1,000 system made of 4 or 5 panels. And then next year, add another 4 or 5 panels to it. And then a year later, add another 4 or 5 panels. As I find panels, as I can afford it, just add more panels. And then my system would then use more and more of the DC side as I have more and more available to give it. I mean, I know it's more complicated than that. I mean, because then you get issues with intermittent power draw, when it draws, how much it draws, buffering it, batteries, etc. I know it's a lot more complicated than that, but there should be a way to do that. There should be some feasible way to do that. Like the first thing I want to do in here is, take all of my lights in the house, all of the ceiling lights and the ceiling fans, off the grid. Hey, John. At first, I'm going to plug it into a single outlet. Now, I can do that because they're all LEDs. So my total power consumption for all my lighting is very low. And the ceiling fans don't take a lot of power. So I want to run my own conduit down the length of the house and plug all of my ceiling fans and light fixtures into that conduit. Have that run to my utility room and just plug it in. So no different than what I have now, except now I have them all isolated. Now, in a power outage, I can take one of my battery boxes and there you go. All the lights work now. And then as I have more money and I can attach some batteries in the solar panel, and all I have to do is unplug from the grid and plug into my own system. Because it wouldn't take all that much battery power to run the lighting. Because it doesn't, it's not that much power. You size it for if everything was turned on, and even then it's not that much. I mean, how many bulbs do I have? I got 3 in the bathroom. I got 2 in my bedroom. I got 3 in the kitchen. I got 2 here. That's 10. 1 in the hallway, 11. 2 in Michelle's bathroom. That's 13. And then 2 in her room and 2 in this room. That's 4 more. That's 17 bulbs at 9 watts each. So 17 times 9. That's 153 watt hours if I had every bulb turned on. The ceiling fans, I don't know how much power they consume. I'm going to say 100 watts. I don't think it's that much. But let's say it's 100 watts. And there's 3 of them. That's 300 watts. Let's call 75 watts each. That's 225. That's 378 watt hours. So I need overnight run times 10. That's 3,780. We never run them on high. They're always on the lowest setting. So they're probably more like 40 or 50 watts. I'll have to actually put a meter on them. So I would only need a battery that's 4 kilowatt hours. A 4 kilowatt hour battery would be sufficient to run this. How much is a 100 amp hour battery? 12.8 times 100. That's 1.2 kilowatt hours. So I would need 3 of them. So I would need $700 worth of batteries. So times 3. So actually, I've seen them as low as $619. So one $600 battery will get me 3.8 kilowatt hours. Now I just need enough solar panels to charge that battery up. So again, everything turned on. So that's 153 times 2, or plus 2. 153 plus 225. 378 watts. Times that by 2, because I want to recharge the battery. And then times that by 2 again, not double, but another 378 for solar efficiency losses. And I need 1.1 kilowatt hours of solar panels. So even on the worst winter day, if I had 3 400 watt panels, that would be enough to power all the lights and all the ceiling fans in this entire house 24/7. Well, that's why I want to have my own separate grid, so that the power grid doesn't matter anymore. I would still have my solar panels if the power went out. And but that would allow me to do all the lights and all the ceiling fans on off-grid power. Now, because on average a third of them are on at any one time, that would actually be enough for 2 days worth of power. And I could probably do it with a single solar panel. One 400 watt solar panel would probably be enough. In the wintertime, the ceiling fans aren't used at all, and we never have more than 5 or 6 light bulbs on at any one point in time. So in that scenario, in that situation, a single solar panel and a single 100 amp hour battery would probably be enough to make my lights completely off grid. Matter of fact, the hardest part of that entire thing would be running the conduit on the ceiling. The next thing that I would want to take off grid would be a 50-50 on off grid. So plug that mini split into a battery and a inverter and a solar panel, and then during the day run it on a solar panel, and at night run it on the grid. And bonus, if I have enough battery power to run it on batteries until 10:30 at night, because that's when power gets more expensive. But I'm not aware of any way of switching over power. Like, how would I do that? Without me having to, every single day, twice a day, walk up to that thing and unplug it from the grid and plug it into the batteries, and unplug it from the batteries and plug it into the grid. I'd have to switch it from grid to solar in the morning, and then switch it from solar to grid at night. Manually. I'd have to manually do that, which would be a royal pain in the ass. And I could set up a relay system to do that. But then you have the system's not going to turn on. So, well, actually, in theory, I could do that. If I had I would have to have 2 batteries. I would have to have basically a UPS, because the UPS would handle the power while switched from one to the other. That would work. No, the problem is when even if I set up an auto relay at a certain time, turn this one off, turn that one on, the air conditioner would reset and it would turn off, and then somebody would have to, with a remote, turn it back on again. It's not mechanical, it's electronic. But if I had it plugged into a UPS, the UPS would simply provide power during the switchover. So that could work. In fact, if I could fix that UPS, I have everything I need. I can use one of my smart outlets to turn the power on and off, and I could use the solar panels to charge the UPS. So MPPT controller directly to the batteries in the UPS. And then during the day, when the solar panels were getting enough power, the relay would turn off the AC power from the grid, but the batteries would stay charged because they're connected to the MPPT controller and the solar panels. And then as the solar panel power waned, that's the other problem, is I'd have to monitor the power. Unless I had a big enough battery, let's say a 1 hour runtime, I would need a kilowatt hour battery. So a single 100 amp hour 12 volt battery would do that. This way, if the clouds came over or something like that, it would still have enough battery power to run until the sunlight came back. But that could theoretically work. Ideally, I would want like a 5. See, that's the thing. I would need a 5 kilowatt battery to run that 6 hours from 4:30 to 10:30. Because ideally, that's what you want to do. You want to run on the battery from 4:30 to 10:30 when electricity costs 20 cents a kilowatt hour. Once it's 10:30, it's only 11 cents a kilowatt hour. I don't care. Switch back to AC power. But again, how much power would you save? How much money would that save you? And how much would that cost you? It would cost you a lot. It would cost you a lot more than just paying for the electricity. But it's fun to think about, though. It's fun to, how much can I do? What will the budget and the technology let me do? It's fun to think about that kind of stuff. And I still think it's okay to print electrical outlet plates with PLA. I mean, for Christ's sake, they sell wood. But, yeah. As soon as I have a tester to test this one, I'm going to release this one for free so everybody can try to print and fly this. I just need somebody to test it, make sure it works. I have one guy who's going to test one for me. He's going to fly the Red Nova, and if that one works, then this one will work too. There you go. This is the Dash. I'm calling it the Dash. So I'm going to release that one soon. You can put up the 24 millimeter motor mount in here. See, that's the cool thing. And that's the reason for the bigger rockets why I want to be able to 3D print these quick links for attaching the parachute. Because by nature of the design, the parachute has to go through the rocket to the parachute. So how do you change the motor mount if it's got something attached to it? Well, you have a quick link. And so I could take the motor mount. This is why I like the MRS system I came up with. I only have to make one 24 millimeter motor mount. I don't have to make 10 of them for 10 rockets. I can make just one. And I can unscrew my 24 millimeter motor mount from this rocket and I can take that and screw that 24 millimeter motor mount directly into this rocket. That does not want to go in. Right there it goes. I can screw that motor mount into this rocket, and there you go. Now this rocket's ready to fly. Then I just have to, attach the shock cord to the quick link, and I'd be good to go, and I'd be ready to fly the next rocket. Because it's a pain in the ass making motor mounts. So now I only have to make one. And I can swap it from rocket to rocket. That's what makes it cool. Or I could take the 24 millimeter out and put an 18 millimeter motor mount in it, or even a 13 millimeter motor mount. So that modularity, the ability to swap that motor mount like that, allows that to be possible. That's exactly what got me into 3D printing, was these things right here. This here is the reason I got into 3D printing. Now, of course, it's a bit different when the nose cone's this big. This nose cone here would cost, $10 to buy from a vendor, or $8 or whatever. But, 13 years ago, my 6-inch nose cone for my big rocket, we're talking, where'd that nose cone go? We're talking this size nose cone here. Oh, there it is. I see it. It's right there. There it is. Seriously? Can't reach it. But once you start talking nose cones this size, they get very, very expensive very quickly. You know, a nose cone of this size is going to cost you $60 or $70 to buy one. Oh, I got a nice little echo out of that one. It sounds like an old radio station. I can print this nose cone for about $1. I mean, this one's hollow, so this is a hollow nose cone. You know, and of course I do the more substantial nose cones now, so maybe it'll cost me $2. Wow. Hey, Paul Cumber. So I vowed that I would never. Now, proviso here. The vendor did nothing wrong. He wasn't price gouging me. He wasn't screwing anybody. That's just what that costs. You want to buy a pre-made vacuum or a pre-made injection molded nose cone from somebody, it's going to cost you $60 or $70 to buy a bigger nose cone like that. And that was a discount price. That was a cheap price. That's just what that cost. He wasn't price gouging. He wasn't taking advantage of anybody. He wasn't doing anything wrong. But when you're someone like me on a budget, that hurts. That hurts a lot. I laughed at first. I thought he was joking, and he realized I thought he was joking. And he's like, "Chris, it's $50." I was like, "You're serious?" He's like, "Yeah." He's like, "Welcome to high power." And it probably costs a lot more than that today. But as soon as I saw that $600 MakerBot Mini on eBay for $600, I dropped the $600. You know, before that, you weren't touching a 3D printer for less than, you know, $2,000 or $3,000 unless you built it yourself, and the technology wasn't quite refined yet. And then very quickly, I got the Wanhao Duplicator i3V2 and started printing all the upgrades for it because it was a piece of garbage, but it was a good piece of garbage. But yeah, even an Ender 3 can print a nose cone that big. An Ender 3 can print any size nose cone you need. You know, that's, you know, 250 millimeters tall. That will fit on an Ender 3. It's one of the reasons why I went to two-piece nose cones, because I needed this shoulder to be longer to properly seat inside the rocket. And it was too wibbly wobbly with a short shoulder. And by making the nose cone two-piece, not only was it now more configurable, because I can now take this part out, so you have the nose cone and you have the coupler, but now I can use the full build height to make the nose cone. So the full build nose cone, then I just screw this onto the bottom of it. This does two things. One, I now have a hole here that I can tie a shock cord to, and number two, I can now use this space inside here. So I can stick an altimeter in there, for example. The top is open, so I can it breathes, so I can stick a little Jolly Logic altimeter inside there, and there you go. I got a payload bay for my rocket, and then this just threads right on there, just like that. And now you have your nose cone. And I can make that shoulder as long as I want. Hell, you can even put the motor mount on the nose cone if you want. These are all interchangeable, these parts. There you go. Fly that. It's not going to fly very well, but it would look cool. But yeah, this is fun. This is a lot of fun. I mean, I know this will fly. There's no question this will fly just fine. I mean, obviously it's going to fly. It's got plenty of stability. It's got plenty of fin area. It's more than stiff enough. There's no question this will fly. The question, however, is, will the plastic survive the ejection charge? That's what I need the tester for. So hopefully he'll fly that soon. He's going to be flying this one. The Red Nova. It's got stuff on top of it. If that one works, it's the same exact airframe, just different fins. So as long as that works out, then I'll be able to start releasing these. And what I think I might do is release all of the 20 millimeter airframe models for free. So put those models on Thingiverse and printables so anybody can download them and print them. I mean, you basically be limited to 13mm motors. And if you want to fly the bigger ones, I'll sell the files to try to add to my income. Because right now I'm not making enough. I'm making about, I'm down to about $400 a month. I need about 700. So I need to increase my income by about $300 a month. Reliably. And so I'm going to try to start selling rocket kits. But I guess I got to wait until they're tested. I can't sell people an untested product. So I got to wait until the testers come back and with success reports. I'm confident it'll be fine. But I still need those results to make sure. But yeah, here's one of the 13mm ones. So there's the tube fin one. There's the Citadel. No, because the helium only has helium only has a limited amount of lifting power, and you're never going to fit enough helium in there to be able to lift that much weight. Like if I sealed off the end of this nose cone and filled this with helium, it would not float, because the lifting power of that much cubic centimeters of helium is not greater than the mass of this cone. You would have to this thing would have to be printed with like a 0.01mm nozzle. Like even a 0.1mm nozzle would still be too heavy. It's just not going to work. I mean, this model only weighs, 20 grams. So this model only weighs 20 grams, 25 grams, something like that. But you can't fit 20 grams of lifting power of helium inside that. It just doesn't work. If you filled your pool toy with helium, it would not float. Oh, man. So there's the difference in scale. Well, the CO2 cartridge alone would be 100 times heavier than the lifting power of the volume of CO2 you could fit in the CO2 cartridge. I mean, if you filled a helium balloon that was 2 feet across, that wouldn't lift that CO2 cartridge. CO2 cartridges are heavy. A CO2 cartridge weighs more than 2 or 3 of these rockets. Here's the scale difference, by the way. This is the 39mm, and this is the 20mm. So these are the exact same rocket, just different size. Sadly, I can't just scale them. I can't just take this and scale it up to this. I have to actually re-engineer the whole file, because all the gaps for the ribs and stuff, it changes. The helium you can fit in a CO2 cartridge can't lift itself. So if you can't lift the container for the helium itself, if that's already too heavy, well, adding the mass of a rocket is just making it heavier. It just doesn't work. It's not about you lifting it under rocket power. It's about you lifting it under helium power. Even if you used hydrogen, which has twice the lifting power of helium, it's still not, you're not going to get enough. Even if you filled that CO2 cartridge with liquid nitrogen, good luck, you still would not have enough volume of gas to lift even the CO2 cartridge. Why do you think hot air balloons and helium balloons are so enormous? No, that's the nature of this particular filament. This filament is a translucent filament. So that's on purpose, because I chose this filament. If I were to print that with an opaque filament like this, then it wouldn't be see-through. Or white like this one here printing now. So you can see you can't see through that one. Oh, not there. So you notice you can't see through that too much, because that's an opaque filament. That's the Starlight, by the way. I was thinking a transparent blue filament would look pretty cool for the Aquarius. I want to try to print a giant upscale one for the Rocky Mountain Rep Rap Festival. I'd like to print one of these, 7 feet tall. I think that'd be fun. But that's a lot of printing. I don't know if I have enough time. Interestingly enough, I can't just turn on more printers because I don't have the money to pay the electric bill. Like this printer here is costing me $20 a month to run because I'm running it basically 24/7. And this printer consumes about 220 watts of power. So that would be about $20 a month to run this printer. Well, you got 5 of them, turn on 5 of them. Sure, I would need $120 to pay for the electricity to run those 5 printers. When you're running 1 or 2, it's not a big deal, but when you start running them 24/7, or they're always on, it adds up fast when you add more printers. Nice. Now, the only thing is, I'm not a super big fan of the way he did his vase mode. It's, the outer skin is janky and not super nice. I think the way I did it was better, although I don't know which way's lighter. So here's my vase mode wing. And with my vase mode wing, the entire outside surface of the model is solid. So there's no floppiness. This actually has structural integrity. This has strength. And these are just ribs that cut into the model and touch this side to fuse it together. Basically the same way I do the rockets, except there's no clean through because you don't need to. You have a single outside surface. But that's the way I do buy it. And here's what it looks like when you look through it. You can see the ribs in there. And then on this side, it looks like that. And I think that's going to result in something better. And this is with a 0.6 millimeter nozzle. I could reduce the weight by 50% just by using a 0.4 millimeter nozzle. And I think it would still be strong enough. Oh, yeah. On this right here, the ME40. Now, this is unusually strong, and it's also heavy as a result of being that strong. Let's weigh it. I haven't actually weighed this one. I found out the slicer's predictions on weight, not even close. The slicer's telling me this is 600 or 700 grams, or I'm sorry, 450 grams, something like that, 480 grams. I weighed it. It's what was it? 140 grams. It's only slightly heavier than the stock one. You asked about that, George. This is 4.8 ounces as you see it, and this is 115% upscale. So the stock one is only 4.2 ounces. So this being 15% larger is only a half an ounce heavier than the stock one. So I'm impressed by that, and I can make it lighter. So this wing is not horrible. 57 grams. So I can get that down to about 40 or 45 grams if I printed this with a 0.4 millimeter nozzle. And I think it would still be strong enough with a 0.4. I might need to add a couple more ribs, maybe. But I think it would be strong enough as it is. Well, the benefit to this is that you have a solid part. His parts are noodles until you glue them together. This part is solid. And also, you have a closed bottom and a closed top. But his way is a lot easier to do. This takes a lot more work. Not for this, really. This didn't take that much work. Most of the work was bending Tinkercad to my will. Like, for example, that pattern that you see, they don't actually touch. So this line here doesn't actually touch this line here. And it can't. You can't have intersections in vase mode, because that creates an island. The intersection breaks the continuous extrusion, and you end up with an island. So I had to actually space these out just slightly so that they come close, but they don't cross. And then I was able to print that. And of course, you also had the problem of thin print, and so your layer lines start to get a little rough because the part's wiggling around a little bit because it's, you know, it's 300 millimeters tall. There's ways around that, but they're annoying. Like, for example, the way I would fix that with this one is when the print got to about this high, I'd glue a skewer, a bamboo skewer, hot glue, one on this side, one on this side, to stop this wobble. I was also thinking that sandbags might work. Little bean bags. Gently place one on each side after it prints a little bit, and the bean bags would help stabilize the model. But if you ended up moving the model, then you'd ruin it. You can do that to this too. You can control the thickness. Like, that's actually something I thought about. What's the best way to show that? I'll show you what I'm talking about. You see, I take the minimalist approach, as little plastic as I possibly can while still completing the mission. But there are other things you could do. So, for example, let's say we're going to... Let's say this is one surface of the wing. And we're going to attach a rib to the wing. A standard conventional rib is going to look like this. I'm exaggerating this to make it obvious what's happening here. So your standard rib is going to look something like this. So Control D. Control D. Let's make this longer to illustrate this. Let's make this an easier on the eyes color. Okay. So your standard rib is going to look something like this. Okay. So you have, this is like, think of this as my tube, as one of these tubes here. So this is the outside of the tube. This is the inside of the tube. And because of the cut that I put in the tube, that causes the tool pathing in the CNC software, the G coding, to do this. It comes here, it goes in, it goes sideways, makes a U-turn, comes back out, and then continues on. And each of the ribs in my model is basically one of these. Now, the important thing is this gap here. The distance from this point right here to this point right here needs to be 2 times the thickness of the nozzle. So this is a 0.4 millimeter extrusion. This total is 0.8 millimeters. This gap would actually be 0. I'm showing the gap here so that we can see what it's doing. The reason for that is that it can't just go out and come back, because if it went out and came back, it'd be traveling on top of itself. So it has to actually make a right-hand turn And when it makes that right-hand turn, there, no matter how small that is, there needs to be enough space for this 0.4 millimeter extrusion right here. So you got this 0.4 millimeter and this 0.4 millimeter. So you need a 0.8 millimeter distance from this cut to this edge. Now these slicers do have a tolerance. So for example, I actually make my cuts 0.75 millimeters. So 0.05 of a millimeter smaller than it should be. But the thin wall behavior in the slicer compensates for that and allows me to get a valid tool path. And by doing it at 0.75, I guarantee that this is going to fuse with this. And that fusion is where you get all your strength. You know, like this has a gap, but it's actually fused. This is a 0.01 millimeter gap, and because we're over extruding slightly, this is fused into a solid 0.8 millimeter wide strand. And then this is fused together here. So you get that integrated structure. It's not just floppy inside here. Now, I can change this. So, for example, let's join these legs together just to make this easier to see. I can put this down here and make this wider. I don't know why I'd want to do that, but I can. That would actually make this less rigid, and it would make it a little bit more flexible, because now this could flex a little bit. So if you had an unusually, video cassette, if you had an unusually rigid material, you could do this to create two ribs going out to the part here. And this gap would be a flex point, because it would permit that to flex a little bit. So if you needed some strength, you could do that. You could also do this. Now, not exactly this. It would be more like, why do you do this to me? So it would be more like this. Control T. So it would be more, you could do something like this. Imagine these two little pieces here are not there. Okay, so imagine those are gone. So the filament would come down, come over here, go across here, and then come back here. So what I've done is I've just increased the footprint of this path on this path, giving me a stronger, more rigid bond without making this bigger. So now I have the stronger, wider bond without losing my rigidity. You can do that too. It's more complicated. It's a pain in the ass, but you can do it if you want. But you can do stuff like that. You can change the shape of the contact patch with the rib and the outside wall. I was actually thinking about doing that because if we flip this around and think this is the cut that goes all the way through, and my concern was when this cut got to the inside of the model that the ejection gases could force this open. Well, what I could do is this. I could do something like this. Where when this came back into the inside of the model, it actually had a lip on the outside here, and this was the cut. So now, as this became pressurized, it would actually push these seams together. That would make the interior seam a lot stronger. But then we found out that it actually was a problem with the slicer. It was making this seam thinner because it was using adaptive extrusion. And by making this thinner, it was able to separate. Because when I print them, I mean, I can destroy the part and it still never separates. So I know the bond is capable of being strong enough. But that was an idea I came up with. It would be complicated. It'd be a pain in the ass, but in theory, it's doable. To allow me to have a more geometry to my slices. But that's essentially what I'm doing. Now, the way I do a complex part, I guess the easiest way to show you how I do the problem is when you do a complex part. Because the gap between this gap here has to be uniform on the z-axis. Now, when it's a square, it's really, really easy. I'll show you. So if I were to take a square like this, all right, so here's my square, and I want to put a rib inside this box. So let's say I'm doing this. So I have this box, and I want to put ribs in this box so I can print this box in vase mode. Well, I need to make a rib first. So here's a rib. And I'm going to make this rib 0.01 millimeters. I'm just going to do this to make it easy. So there's my rib. This is actually pretty easy to do. All I have to do is align these parts along this edge. Okay. Now, this rib is sitting flush with this edge. Now remember, I need a gap 2 times the nozzle diameter. So all I do is grab this, shift it, oh, I'm hitting the control key. Shift it sideways to 0.8 millimeters. Absolutely, you can ask some 3D printing questions. That's what we are. And now I have a rib that I can cut into the model. I'm going to make this rib a little thicker so that you guys can see what I'm doing. I make this hollow, I make this solid, and I join the two of them together. So there you go. You can see here, now I have this object with a rib that's the correct size. It's the correct dimension. Well, here's the problem. Do that with that. Now it's a lot harder. I can't just take this and squish it down to a rib and use that as a cut because I need to offset it. And I can't scale it because when you scale something, you change the relationship between the surfaces. The relationship between these surfaces is linear. The relationship between these surfaces is nonlinear. So the way I have to do that is I have to actually take this rib and translate it sideways. But now it's sticking too far out on this side. So now I need to take half of a rib. And now I can translate that rib sideways. And I have to do that for all the ribs all the way around the model. And then when you get into, this is relatively easy because this is, it's non-linear on the z-axis, but it's linear on the x and y-axis. So I can just do this. I can take this, copy it, and revolve it. And keep copying it. And I can revolve that shape around. And that will work. But now, if you have a shape that is non-linear on all 3 dimensions, you have to make a custom rib for each angle, and it's a pain. Okay. My main printer, Enter 3 Pro, seems to have clogged nozzles about 2 times or 3 times a year. Using the acupuncture needle doesn't clear the blockage. I end up replacing the nozzle with a wrench. Is this normal in your experience? No, it is not normal. There is no such thing as it doesn't clear with the acupuncture needle. The acupuncture needle always clears it. Do you mean it immediately reclogs again when you clear it? Or do you mean it really does not clear it? So you're saying you punch it with the acupuncture nozzle and then it reclogs? Or is it really just not going through? I have never ever once had to replace a nozzle because of a clog. Not once. So that we got to figure out why you're clogging first. Okay, so it is clearing it. It's just not enough to work. So that means you're immediately reclogging. We got to figure out why you're doing that. Exactly. So you haven't fully cleared the clog. You still got crap in there. Good. So now we know that you're getting a hard clog. So something is stuffing the nozzle. We need to figure out why. Um, Now, when you replace the nozzle, do you also replace the Bowden tube or do you just replace the nozzle? So you don't even clip off the end of the Bowden tube. You just replace the nozzle, that's it, and you're good for another couple months. Huh. That sounds like a hard clog. Like there's actually something in there clogging it up. Um, because if it was a Bowden gap, replacing the nozzle wouldn't fix it. And you're printing with silk, which is usually a pretty clean filament. Is the environment dirty? Is this like in a garage or a basement? Is there a lot of dust and dirt? Okay. So most likely what's happening is this is my guess, of course. This is a guess. You got to test it and try it. My guess is you have contamination getting into the hot end. You have stuff getting into the hot end that doesn't belong there. Dust, dirt, fiberglass, etc. Yep, that's usually what it is, but his is not because his goes away when he replaces the nozzle. And if it was a Bowden tube problem, the problem would not go away. So my guess is the dirty environment is being attached to the filament. The dust is gathering up on the filament, and that is making its way into the hot end. Inside the hot end, it gets attached to the walls of the brass. It cooks off, and it eventually forms a blockage. Now, of course, this stuff doesn't melt at 450 degrees Fahrenheit. It doesn't melt at 200 C. So it's going to stay there. It's not going to, if it can't be carried out by the filament, it's going to stay there until it forms a blockage. That's a hard clog. The only way to fix that is to, one, continue changing the nozzles, or two, prevent the dirt from getting into the environment. And yes, you can do something about it. You install an oiler on your printer. If you look up oiler on Thingiverse, you're going to see these little clamp-like cylinders that have a hole going through it, and you put a piece of foam inside of it. And normally you'd put some oil on that foam, and it would oil the filament as it's going through. Well, you're going to use one of those. You're just not going to use any oil. The sole purpose of yours, and you're going to want to stretch it out, make it long. You're going to want it to be about 2 or 3 inches long, and then you line both sides with foam, and you just let that sit right on top of your hot end going into your printer. Well, yours, if it's a Bowden, it would be at the feeder going in. So you put the sponge, not, I say foam, but I mean sponge, not like styrofoam. You're going to basically use the sponge cleaner dry. And what it's hopefully going to do is scrub off the contamination that's getting on your filament as it's going into the printer, so that you have cleaner filament going into the printer. It's not going to end the problem, but it will reduce the problem. And also, a cold pull might work. It all depends on how cemented the contamination is to the side of the brass, but a cold pull could also help. And yes, you're right, nylon is very good for that. Silk might be very good for that too, because silk has that stretchy nature that nylon has. So basically, you either need to get the contaminants out, or you need to prevent the contaminants from getting in. So the two things you can do immediately is to, number one, print a cover for your feeder. And put a cover over top of the feeder so that dust doesn't fall where the gears are inside there. And then put that oiler with the sponge material in it, but no oil. You're just going to use it to clean the filament. And put that on top of the, when your filament goes into the feeder. The other thing you can do is print a cover, or make a cover, or use something existing. Print a cover to put a cover over top of your spool. So literally what you're going to want to do is something like this. So there's my spool cover. So literally, you want to make some sort of a cover and put that cover over the filament. So that now dust falling in the room doesn't get all over your filament roll. You're going to want to use something rigid so it doesn't get caught up in anything, but some kind of like a bread box cover that you'd 3D print that would just sit right on top of the filament roll, and that would keep the dust from gathering up on top of the roll. And then you also want a small cover for the feeder unit here. So 3D print a cover that just loosely sits on top of this, and that will stop the dust from getting in here. And then your oiler with just a dry sponge inside, and then once a week take the sponge out and clean it. You'll see it gathering up gunk, but all three of those together will keep your filament clean as it goes into the printer. It'll reduce how much contamination you have. And then you're also going to want to learn how to do a cold pull, because no, that's not normal. I've never had to replace a nozzle because of clog. Never once. Not that kind of frequency, at least, that's for sure. The a cold pull. Well, here's my very simple cold pull. There are probably better ways to do it, but this is my simple method. Heat up your hot end 220 Celsius. Okay, you want real good flow. Now manually push filament in. Take your hand, squeeze the tensioner, push filament in. You're gonna feel it going in really easy at first because you got all that liquid filament in the end. And then as you introduce fresh filament, you're gonna feel it slow down. It's gonna resist. It's gonna be harder to push. Do that a couple times. When it becomes harder to push, stop. Let the hot end get hot again. Do it again. You're gonna feel it. You're gonna go, ooh, that's easy. And then, ooh, harder, harder, harder. And then you're gonna reach a balance where it takes the same amount of force to keep pushing. Learn and recognize that difference, because that's going to be important. Once you've learned to recognize that difference, what you're then going to do is you're going to push fresh filament in, and then you're going to turn off the hot end, and you're going to watch the temperature drop. When your temperature gets to about 200 Celsius, start pushing. Grab the filament and start pushing it in. Keep pushing, keep pushing, keep pushing. At some point, depending on what filament you use, depending on your hot end, it could be 180 degrees, it could be 170 degrees. You're going to notice that the amount of force that it takes you to push that filament in is going to become exponential. It's going to go from harder, 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 harder. Oh, it's really getting hard. When you get it, when it's really hard to push, when you almost think you're not going to be able to push anymore, in one fluid motion, you reverse and stop pushing and begin pulling. It might resist. It might resist a lot. This also might work better if you remove your Bowden on the top end here. But the problem is, if you have a lined hot end, that's a pain in the ass. So you might not want to do that. If I were to do that, this is on direct drive machines where I did this, so it was easier. If you really want to make that easier, break your Bowden tube in the middle and put a coupler. This way you're not futzing with the Bowden tube inside the hot end. But push, 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 push as the temperature drops. Harder, 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 harder. Oh my God, I don't think I can push anymore. Fine, stop, turn around, pull back. One fluid motion. Push, 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 reverse pull out. Once you pull out about that far, you don't have to pull out so hard anymore because you're out of the hot end now. It might be very hard for you to pull it all the way out because the end of that filament is going to be bulged a little bit, and now you're trying to pull that through a Bowden tube that's a little too small. But you can get it out. Just keep pulling and pull that out. And if you do it right, well, you can't do that with a Bowden. You're probably going to tear apart the hot end. Like I said, this is a soft cold pull. I don't let it get fully cold. But if you do it right, the end of the filament will be the shape of your nozzle. You'll see the filament come in. You'll see a sharp line where it goes dink, dink, because it's slightly bigger inside the nozzle. And you'll see that nice little sharp little, triangle where the nozzle actually meets. And then you'll see the little tiny hair sticking out the top that was sticking out of the nozzle. If you do it right, that's what you'll see. Let me see if I can find a picture for you. Here we go. Perfect. If you do it right, you'll see something like this. Right? If you pull it out hot, this is what you're going to get. It's okay. This, you got a good pull. We move this out of the way, and you'll see this here. That's where the PTFE tube joins with the metal inside. Now, your older one is going to be if this works correctly, if the cold pull works, you're going to see crap here. You're going to see stuff on the end of this. So see how he has got gunk on here? He's got a little black stuff there, this brown stuff here. That is stuff that was caked up inside the nozzle. And that is what would eventually form your clog. Theoretically, you want to do this 2 or 3 times until you get a clean pull like this. You have the shape, which means you were cold enough, and you don't see any contamination. Now, that could mean there's no contamination, or that could mean you can't get rid of the contamination. Either one is possible there, but this is what a cold pull is. Now, is that going to fix your existing nozzle that you just replaced? Probably not. That's probably too far gone. You probably baked off too much crap inside of there and it's done. But if you do this once per week, do a nice cold pull once a week, you'll probably be okay. You'll greatly extend the life of the nozzle. Yep. So your root issue, now again, this is a guess. This is a guess on my part. I don't know your specifics. But my guess is your dirty environment is introducing contamination on the filament. That contamination is being brought into the hot end, but it can't melt. Now, if it's small enough, it just continues on out with the filament. But if it's large enough to get stuck in there, or it gets adhered to the side of the brass, it's going to now create a drag point, which is going to make it harder to push filament, and it's also going to create an attachment point for more contamination to get stuck. Yes, you do. If you're not careful, if you get laissez-faire with it, you could damage wires. Yes, I've done that. Somebody called my name, turned around, kept turning the wrench, ripped those friggin' wires right out. That sucked. Oh, man. And worse, your printer's powered up when you're doing this. So if you short those wires, you could fry your brain board. Not fun. Yep. Oh my God. I remember another time I was clipping a zip tie off of the wires, and I wasn't paying attention, and I snipped right through the entire stepper motor wire. Oh, I had to rewire the goddamn plug for that stepper motor. You are near the wires because the wires are going into the hot block, which is attached to the nozzle. Exactly. But what we're saying, though, is if you goof that up, if you make a mistake, if your wrench shorts out those wires, or if you don't have it clamped right and you go like that and it turns, you're increasing the odds you could damage something. You're doing it right, but the more you do that, the riskier it becomes because eventually you're going to make a mistake. It's inevitable. We're human. So do a cold pull once a week and make covers for everything. You should be able to 3D print your cover so that you can put a what I would do is the spool holder. I would 3D print a bracket like this that I would attach to the spool holder, and then I would 3D print a cover that's bigger than the spool and bigger than the spool holder, and it would sit on top of that bracket, and I would just lay it right on top of the filament. This way it's a hard cover. You take it off, change your roll, put it back on. Make it as easy as possible, because if you make it hard, you're not going to do it. So have a cover for the roll so that dust doesn't settle on the roll. Have the oiler dry going into the feeder. Have a cover for the feeder so that dust doesn't settle inside the feeder unit. And then do a cold pull once a week. And you'll probably get years out of your nozzle instead of 6 months. But yeah, that's my guess. My guess is external contamination is clogging up your nozzle. And once that contamination gets large enough that it can't clear by being pushed through with the molten plastic, well, you've just started your doom clock. And eventually it's going to build up enough that it just jams up your nozzle. That's why you could push the needle through, but it doesn't fix the problem, because the needle can't clear the junk that's inside the end of the nozzle. It would be interesting to try to hey Darren, it would be interesting to try to extract the contents of that nozzle to see if you can see what's in there. You can't use a torch because you'll just burn whatever's in there, and you won't be able to tell the difference between contamination and burnt filament. But if you had a controlled way of heating that up enough, boiling water maybe, basically do what you're not supposed to do. Push filament in. Do like the cold pull thing I was telling you to do. Well, you can't anymore. But what I would do the next time that happens is I would force some filament through and then turn off the heat. Don't pull it. Don't touch it. Snip the filament at the speeder. Do what you're not supposed to do. Unscrew the nozzle with the filament still in there. But because you snipped it, now when the nozzle comes out, it'll take out that piece of filament with it. So now you'll have a nozzle with a piece of filament stuck in it. Now, probably the easiest way would be I'm thinking a pair of an adjustable wrench, and then a pair of channel locks on the outside of the adjustable wrench squeezing the nozzle. Heat up the channel lock or the adjustable wrench to heat up the nozzle until the plastic starts to go, starting to soften, and then take off the heat. Wait a bit until the plastic hardens up a little bit and try pulling it out and see if it extracts whatever's in there. It'd be interesting to see what's in there. You can't dig it out because you're just going to destroy whatever's in there, and you won't be able to tell the difference between debris and clog. But it would be interesting to see what's in there. But yeah, cover the spool, cover the feeder, oiler with a sponge going in. Let me see if I can find one to show you. Here we go. This is it right here. See? That's all this is. Except you're not going to use oil. It is this thing number. You're just going to put a piece of sponge on each side or whatever you want. You're going to put something in there that's going to squeeze this filament. Here, that's a good cold pull right there. See? That's a halfway decent cold pull right there. Um, but this will basically, it'll scrub your filament clean as it passes through this. And this will you just snap it over the filament and it'll sit right behind your feeder. And your filament will slide through this, and it will, anything that your covers don't prevent getting on your filament, this will hopefully scrub it off and keep your filament from sending dirt into your hot end. Also, make sure all of your rolls of filament are sealed or in containers of some sort. It doesn't have to be airtight. It just has to be dust resistant. You know, like a bucket with a loosely fitting lid is enough. Rubbermaid container, anything to keep the dust in the attic from settling on the filament. Because you're going to have asbestos, you're going to have fiberglass, you're going to have asphalt, you're going to have cement, you're going to have wood shavings, you're going to have fabric shavings, you're going to have skin, fur, and fluids from animals and critters and insects. You're going to have all of that kind of micro debris up in an attic at far higher quantities than you would anywhere else. And that will settle on top of your printer. It'll settle on top of it. And also keep your printers clean. You know, take a damp, every day you go to the printers, just take a damp rag and wipe them down. You know, get all the dust off. But yeah, that's what I would do. Not a lot of work. It's not a lot. Once you have the covers made, once you have the stuff made, I might design a cover. That shouldn't be that hard to design. But once you have all this stuff made, it's pretty easy from then on, just you know, just to maintain it. But hopefully that'll keep you from having to change your nozzles 2 or 3 times a year, because that'd be a pain in the ass. They are cheap, but it's a pain in the ass to do. I'd be annoyed if I had to do that. Oh, man. This is coming out really nice. A fishing bait boil threader? No, your issue is not common. Especially if you are not using filled filaments, like, you know, wood, glass, carbon, etc., which has, you know, content inside the filament. So that is definitely not common. You should not have to be changing your nozzle. I mean, no, no, you shouldn't have to change your nozzle. I've never had to change a nozzle because of a clog. Never once. In tens of thousands of hours of printing, I've never had to change a nozzle due to a clog. So there's definitely something going on there. Especially since you're not running long enough to even have to change the PTFE tube. So you're not running ultra high temperatures. You're not wearing it out. Metallic doesn't matter. It's only if there's a foreign material in the filament. Like wood has wood powder in it. You know, glass filament has glass in it. Glow in the dark filament has glow in the dark powder in it. Fiberglass filament has carbon fiber filament has carbon fiber shredded up and put inside the filament. Meaning there's a foreign agent inside the filament. Really? Most metal filaments have metal powder, but not metallic. Like, this silver filament does not have any metal in it. You know, this is a silver metallic filament, and there's absolutely no metal inside that. You might be thinking actual metal filaments, like what Protopasta sells, you know, that has brass in it or copper in it. Oh, okay. So if you actually have metal filament, then yeah, that could do something too. But I would think a metal powder is a lot less likely to clump, because you're never going to get anywhere near its melting temperature. Well, a short rod will clear a plastic clog. But if you have a foreign agent clog, you're just going to jam the clog in deeper. silk. Yeah, as far as I'm aware, there's no metal in those. As far as I know, there's no metal. Could be wrong, but I don't think so. It would cost too much. Metal powder is actually rather expensive. That's one of the reasons why SLS is not common yet. I mean, they have relatively affordable SLS machines, but the metal powder for the printing process is really expensive. Yep, just try to keep it clean, because you shouldn't have to replace the nozzle that often. That's kind of weird, meaning something's going on. So I want to try to get a giant one of these printed, and I want to try to get an itty bitty one printed, like, you know, that big. I want to try to get a little Micromax one printed. I can't remember what the max liftoff weight of Micromax motors was. For some reason, I want to say 15 grams or 7 grams. I can't remember whether it was 15 grams or 7 grams for the heaviest model you could lift off with a Micromax. Although the new motors can lift more. I hate the new motors. I like the original paper motors. They were so good. What do you mean, how high? I'm trying to build one of the egg printer machines before Easter. You mean it's something to print on or draw on eggs? That's kind of cool. What do you mean, how high can you print PLA to make good bonds? You mean layer height? Or how tall the object will be? I know you want to make strong parts, but what do you mean by how high? What does how high mean? Oh, cool! No shit! Dude, that's cool! Okay, so how high a temperature can you print PLA at to make good bonds? Well, there's what you need is not temperature. What you need is heat soak. So you need a sufficient amount of heat to penetrate from what you're extruding to what you already extruded. You basically need the new extrusion to heat up the old extrusion enough to facilitate a good strong bond. Now, there's two ways you can do that. You can do that by increasing the delta, by increasing the rate at which you transfer the heat, and you do that by increasing temperature. Or you can slow down. You can give the plastic a longer time in the hot zone to melt to the other part. Or you can do both. There is a limit. As you increase the temperature, you also make the part more brittle. You are basically you're destroying the structural makeup, the chemical makeup, the molecular makeup of the plastic if you make it too hot. So in general, you're better off slowing down rather than heating up once you reach a certain point. As far as what temperature is safe, what temperature is good, I can't answer that. It depends on the plastic. And that's basically something you're going to have to test. If you're using a well-known plastic, like eSun PLA Plus or Protopasta HT PLA, if you're using a good quality, well-known PLA Plus, you could print those at 230, no problem. Maybe even 235, but you're pushing it. But 230, definitely safe. If you have a virgin PLA, meaning a pure PLA, 230 is probably too hot. You're probably going to burn the filament. So those you're going to want to max out at 215 or 220. This also depends on what the actual delta of your hot end is. Like, you might tell it to print at 220, but it's not actually doing it. It might be printing at 215. Some filaments also crave heat, like silk filaments love printing hot. I print all silks at 230. So you can increase the temperature slightly and slow down. Now, as far as strong parts, there are many aspects to strong parts. You have the strength of the plastic itself, the strength of the structure that you printed, and you have the strength of the bond between one layer and another. Removing silks from the equation, because they are a separate beast altogether, but just talking about regular, run-of-the-mill PLA that's not special in any way, you will gain more strength with structure than you will with bonding. You're going to get a pretty good bond. Unless you're printing at some crazy high speeds, crazy high layer heights or nozzle widths, or crazy low temperatures, you're going to break the model before you break the bond. So that's where structural integrity comes from. Now, there's two ways you can increase structural integrity. You can make the part heavier, use more plastic, so increase the amount of infill. Basically change the ratio of the air to plastic. But the way you change that ratio can also influence the strength of your part. For example, infill is substantially weaker than perimeters. So decreasing your ratio by increasing the number of perimeters you print will have a greater impact on the strength of the object than increasing the infill. So, for example, if you printed an object with 3 walls and 20% infill, let's say you wanted to make that stronger. Well, you could print 3 walls with 40% infill, or you could stick with 20% infill and print 6 walls instead of increasing the infill from 20 to 40%. The part with the 6 walls will be stronger than the part with 3 walls and 40% infill, because walls are stronger than infill. Infill is going back and forth, and it's individual lines which are easy to break, while your perimeter is one continuous loop around your entire object. That continuous loop is going to be substantially stronger than a bunch of individual segments. That's why walls make the part stronger. Then you also have the design of the object itself. Can that object complete the mission most efficiently? That gets quite a bit more complicated. It depends on what you're printing. Yeah, I would prefer much more 3D printed parts. Yeah, see, I wouldn't do the second one. I would do the first one. Because the first one's just 2 stepper motors and some screws. In fact, I would probably even try to make my own, just because I'm a glutton for punishment. And I would try to replace all the screws with 3D printed screws, except for the ones going into the stepper motors. That's really cool. That's just freaking cool, man. I prefer more 3D print. Here's the thing. I'm broke. I am poor. I'm about to destroy my credit. I have an 830 credit score. I'm about to have a 300 credit score because I'm about to default on all my credit cards. 3 of them at least, because I'm out of money. But I have lots and lots of plastic. I have lots and lots of plastic. So the more plastic a project uses, the better, because I've already got the plastic. Why do you think I'm making completely 3D printed rockets? I can't even fly them because I can't afford to buy motors to fly them. But you know something? I can make them because I got lots of plastic. That is so freaking cool. Huh. That is amazing. Now here's the real question though. Can you use it without a computer? Is there a way to put the instructions like decode on the memory card, on a memory card, or in the memory of the Arduino? I'd like to try at some point. I would like to try to do that at some point. Um, the question I have is, can we set this up to run without a computer, so we could put the instructions like decode, I guess, um, so that I can run independent, because then I can see making, um, I appreciate it, George. Thank you. Don't get me wrong. I mean, we'll be okay for the most part. Some things are gonna get tough. My brother's gonna help me out with my house insurance for this year. I gotta figure out how to pay him back, but he's gonna help me with that, so at least my house will be insured. Um, we're about to move into the warm season, so my electric bill is gonna be cut in half since I won't be using the heater anymore. Although I have to renew the registration on 2 of the cars this year. That's gonna be fun, and they're increasing the price of my goddamn car insurance again. Why? What am I doing to cause you to charge me more? Just because you can. That's why. Um, but most of it is inherited debt. Yes, I am going to Colorado. I got my tickets for the tables, and even though it hurt paying the $35, I bought one of the T-shirts. Oh, that hurt. But my buddy's gonna let me stay at his place. Although I just found out it's an hour away from the event. Wow, I didn't realize it was that far, but that's okay. I can't afford a hotel room, so that's out of the question. I'm gonna be able to stay at his place. So I hope to get there Friday early afternoon to set up. Be there Saturday, Sunday. I'll stay over until Monday at my friend's place and then come home Monday night. Um, so that's gonna be a lot of fun. I'm looking forward to going to that. And then I have NSL in May. That's 3 hours away. I might only be able to stay for 1 day. It depends on the weather, because I'll probably have to sleep in my car. I can't afford a hotel room. So if it's cool enough, I can just sack out in the car. And so show up Saturday morning, event, sleep in the car one night, and then after Sunday, drive home. Then July and August is NARAM and the World Championships. I think I'll be able to get somebody to help me out and let me stay with them for those events. So I think I'll be able to do that, no problem. I hope. And again, worst case scenario, I'll show up for a day or two. And the big problem is gas. Thank you very much to the person who sent me $60. That's going to help out a lot for the gas. But I do have some gas in the pickup truck and the bus, so I'll be taking that gas with me. There's nothing I can really do about it. In order to sell my house, I had to pay off his debts. And my father's debts exceeded the value of the house. It was about $180 something thousand in debts, and I only got $145,000 for the house. So I had to transfer about $30,000 of his debt to my own credit accounts, credit cards, and lines of credit, in order to get the DTI below 0. to where the house could be sold. I've been carrying that debt for 3 years, and I've run out of money. I can no longer pay it. So I have at least 3 credit accounts that are going to default. Nothing I can do about it. I mean, it's just I've made some mistakes. I've wasted some resources. I should have done less work to the house and paid off more of the debt. But when we first got here, I was doing a lot better with Amazon and YouTube. And then COVID hit and everything tanked. I'm making about a third of what I made when I moved here. I was pulling about $1,200 a month from doing this. And then of course I screwed up. Can't do much with that. It's my fault. Making small tires for Octopus Prime printing TPU. TPU is the TPU you buy on Amazon is actually pretty easy to print. Your biggest thing is reduce your retractions, if not turn them off, and deal with the stringing later. And slow down, like 25 millimeters per second. I don't know what Zyro TPU means. I don't know how. It depends on how soft it is. If you can hold a piece of it like that and it stays standing up, you're probably okay. If you hold a piece like that and it goes, like the really floppy stuff, you're gonna have trouble if you don't have a direct drive. I know Zyro brand, a good brand. I like their stuff. Not yet. I haven't contacted them yet. I'm waiting until I unmothball the electric car because I can't really use it in the wintertime. It doesn't have enough range with the bad battery. But now that the warmer weather's here, I'll be able to use it again. I'm hoping I left it on the charger all winter, which not really good for it. I'm hoping that will have cost me that last battery bar, because if I lose one more battery bar, then they have to replace it under warranty. It's an automatic replacement under warranty. If it hasn't lost that 4th battery bar, I'm going to contact the legal aid. I have this information saved. I'm going to contact them to see if there's anything they can do to help me with that. It's very obviously a warranty issue. It's just in a gray area that they don't want to pay for. What are you going to do? So I've been trying to find some extra work. But again, because of COVID, the only place I can get a job is in Albuquerque. And that's just too far to drive right now. My vehicle expenses will exceed the pay I'll get pretty rapidly. So, and nobody's hiring here in town here. Nobody's hiring local. Because I've been trying to find like part-time job. If I could just find the job that'll give me, even 12 hours a week, 2 shifts a week, 2 days a week, that would be more than enough. I'm actually going to start doing something like that. The people around here like, locally made bespoke stuff, even though everybody is pretty poor right now. Holy shit, somebody just sent me $100. Who was that? Who just said check PayPal? Michael. Thank you, Michael. Very generous. I appreciate that. So people like homemade style stuff here. Oh, yeah, probably don't want to do that. You got people's information there. Sorry about that. Oh, good. At least it didn't show anybody's personal information. Thank God for that. So there's this person on Printables who's making these beautiful rope and weaved styled baskets and containers, and I think that kind of stuff would sell good around here, especially if I use wood filament, because I just have to make sure I source some American made wood filament, because that's going to be a big selling point around here. Wire versus ribbon? Wire versus rib? I wish I could use it for spending money, but no, it's going to bills. I got a $273 electric bill to pay. I applied for LIHEAP and they declined me. I was like, okay, nothing I can do about it. Actually, eating's not going to be a problem. First of all, they'll probably let me sit in for dinner with them a couple times, but also I have 40,000 points on my McDonald's app. So every morning I'll be able to get a 99-cent breakfast sandwich, and every night I'll be able to get a free chicken sandwich and a dollar fry. So food, I got that. I got food sorted. I know how to do that cheap. Plus, I have a solar panel, battery, and electric cooler, so I can bring food with me, and I will. I'll make sandwiches. Actually, not sandwiches, because have you seen how expensive lunch meat has gotten? It's like $6 a pound for lunch meat. I was like, holy crap. Yeah, I'm on I-40. I-40's right out my back window, my back door there. Far enough away that I can't hear it unless the truck puts on the Jake brakes, but close enough that I can just see the trucks going by. So I need to increase how much money I make from this. And that's part of that is going to be undoing all the damage that I did. George, thank you very much for that. Now, do not take this the wrong way. I'm simply providing this as information. If you want to support me with a large amount like that, do it by PayPal. The $100 that I got from Michael, actually he paid the fee, so I get the whole $100. But even if he didn't pay the fee, PayPal would only take like 4%, so they'd take $4. Of the $100 you guys give to me in a super chat, YouTube takes 30%. So YouTube's gonna take $30 of that 100. So that's not your problem. You freaking rock. Okay, you are awesome. But just to let you guys know, if you're gonna donate a large amount, use PayPal. Well, that's what I am. I'm an e-bagger. Yeah, it's crazy. Yeah. They take 45 to 50% of the ad revenue, which is fine because they're providing the platform. But for them to take 30% of super chats, that's mean. And don't apologize. You're awesome. That was incredibly generous. I really appreciate that. But I'm just letting you know so you know for the future, and other people know, use PayPal because they only take a couple percent. uh, the oh, you can get them cheaper than that. Oh, no, no, no. You can get stepper motors for nothing. Stepper motors are cheap. And you don't even need a strong one. So you could probably use small little pancake motors. And I have 100. Here you go. $11.99. They're $12. Yeah, I'll show you. Here's $11.99. That 48 is probably for 5 of them. Oh yeah. Here's $14, $11, $10.99 right there. Here's one for $8.99. Yeah, here, a little pancake motor for $9. And because you probably don't need a full 42 millimeter NEMA 17, you're only turning an egg after all. So yeah, stepper motors are cheap. And plus, I've got 170 printers. I could just take a couple motors off a bad one. It'll be a while before I can make one of those egg things because I probably already have the servos too. I should have some 9-gram servos lying around. It looks like they're using 9-gram servos. I should have some of those somewhere here too. And I don't have the Arduino or the whatever it is, the Nano or whatever it is. I would love to be able to sell used printers.
and I can't do anything about it this year. It's too much work. I can't. There's just no time. I don't have the capability of doing it now, but maybe for next year I can. I did figure out one way I might be able to sell used printers. The problem is, take an Ender 3. First of all, I would never sell an Ender 3. It's too useful. It's too good a machine. But let's say an Ender 3 clone. Okay, I have an Ender 3 knockoff. I want to sell that. It's going to cost me $100 to ship it. If I disassemble the printer, it's going to cost $60 or $70 to ship it. So now, how much can I charge a person for a $100 printer when the shipping is $70? Well, I can only charge them $30. And then I got to pay tax on the $30. Because I do not fuck with the IRS. I report my income. If I sell a $10 rocket, that is going to be in my Schedule C for having sold that. Because I don't really pay much in taxes anyway. I'm a business. I can write everything off. So the only printers that would be worth selling are the printers that I want to keep, because they're the good ones. And the ones that I'm willing to sell, 120 of them that I'm willing to sell, nobody's going to pay me anything for them when they can buy it for less by buying it new. I mean, you can buy a 334 printer for $200 on Amazon, $180. So how much are you going to pay me for a CR10? $50. At that point, it's not worth selling it. I get more use out of it by keeping it. Albuquerque is dead for 3D printing. There's not enough people, not enough demand. I see people trying to sell Ender 3s for retail price, and they sit on there for months before they just give up. There's just Philadelphia was a great market for that. Albuquerque, not a good market for that. Now, there is one way, and I cannot believe I didn't think of this earlier. It's so obvious. I'm crazy for not thinking of it. Sell printers at events in person. So next year when I go to Rocky Mountain Murph, I'll bring a printer or two with me. And if somebody wants to buy one, they can buy one. And next year when I go to NARAM, assuming I go to NARAM, I can't drive long distances anymore. This is the weird thing that this is not a complaint. This is not whining. This is just, it's actually interesting to me. I can't travel for events anymore. I can't travel long distance. People say, but wait a minute, you went to 21 NARAMs and you drove across the country for almost every one of them. What's the problem? Well, back in 2010, when I got in my E150 cargo van and drove 30 hours across the country, back home, I had 3 licensed drivers, a business paying for everything, a pickup truck, and a tow dolly. Worst case scenario, best case scenario, I stop on the side of the road, I hit an auto parts store, and I fix it. Second worst case scenario is they wire me some money, they deposit some money into my bank account so I can pay a mechanic to fix the car. Worst case scenario, my dad and my brother get in the pickup truck with the tow dolly, drive 15 hours out to wherever I broke down, we hitch up the car, and we drive home. Oh, nice. I'll definitely be able to go to that. So I had family. I had a capable network at home that could bail me out if something bad happened. Now, chances of something happening bad are low, but if something bad did happen, I knew one way or another we could take care of it. Either I could fix it myself, they could send me money to pay a mechanic, or if we were too poor to pay the mechanic to fix the car, they would spend a couple $100 in gas, drive out, and get me. I knew we could always do that. But now I do not have that support network anymore. If I drive my car to, Murph in Indiana, and I break down halfway to or from Indiana, I'm fucked. Option one is my only option, to hope it's something simple enough that I can fix on the side of the road. Because my credit's destroyed, so I can't just hand over a credit card and hope I can pay it off later to fix the car. And I've got nobody here who can come out with a tow dolly and tow me back home. And AAA will only take me 200 miles. That's why I've been limiting my trips to 400 or 500 miles. That's 2 AAAs. Call AAA, have them take me 200 miles, sleep in the car overnight, call AAA again, take another 200 miles. So I realize now that I don't have the financial backing to bail myself out of a problem. If I break down, could I get home? Yes, but I'll lose everything. I'll lose the car, and I'll lose everything I have in the car that I can't carry on my person when I get on a bus to make my way home. I mean, I would lose everything I have on me that I can't carry. And that's scary. That's scary, realizing that you no longer have that kind of... I never had the financial backing. We were always relatively poor. But we had resources. We had multiple vehicles. We had our own tow dolly. We had a pickup truck with a hitch. You know, worst case scenario, they grab Chris the mechanic and, you know, they hop in the pickup truck and they tag team drive out to wherever I'm at. And if they can't fix it on the spot, we hitch up the car, we tow it home. We could always do that. Now I no longer have those resources. I have nobody who can help me. I have nobody who can come out and get me. And I don't have the money to pay for any of that. So long distance trips are a huge risk. Even if I could bring all the food with me, even if I could bring the gas with me and stockpile the gas and gas cans, you know, even if I sleep in the car, you know, which is not very healthy for somebody my size, but I could do it for a night or two. Even if I did all that, a breakdown would be catastrophic. It would just be absolutely devastating. If I break down here, well, AAA brings me home and I leave the car in the driveway until I can sell it or afford to fix it. I have 3 other cars. I start driving one of those. But if you're 1,000 miles from home, what do you do? What do you do? If you don't have the money to pay a mechanic to fix whatever's wrong with the car, you're shit out of luck. You're screwed. I mean, holy shit. No wonder people don't make long trips like that. Now I know. Now I know why. Because if something goes wrong, you're in deep shit. And, you know, I'm in that situation now where if I were to make a long trip and something were to happen, something were to break down, I mean, if it exceeded more than a few $100 that I have available on a credit card, I'm in real deep shit. You know, I'm not in danger. I can get a bus ticket and get home, but every possession I have in that vehicle, including the vehicle itself, would be forfeit. Ouch. you know, ouch. So yeah, that's why I was thrilled when they announced the Rocky Mountain Festival. You know, that's a little bit far away. It's a 7-hour drive, but yeah, and fuel pumps can be, sometimes they're easy, but sometimes they're a pain in the ass. So I realized, you know, that's a bigger issue than people realize when you... Now, if you have reliable income, like, you know, oh, wow. Yeah, I've seen these before. I have these downloaded. I have not printed them yet, though. I've seen those before, the eggs. Those are pretty cool. I think I still have Maker Muse's big resolution tester egg, you know, the 3 spinning ones. I made the big giant version of it. You like that? I mean, when you make it that big, you're not really testing anything, but it's cool. So yeah, you know, unless you have that's why poor people don't travel, because, you know, A lot of people in my situation don't have a minivan, a pickup. Like it happened in a minivan. There's something wrong with the minivan. Okay, so I drive the Kia or the electric car. Um, but I can do that. But what if that minivan were my only vehicle? I'd be in trouble. They're all built into the gas tank. Yeah, well, you got to find a friend who has a mechanic, a shade tree mechanic who can help you out with that. A regular shop is gonna ream you to change a fuel pump usually because they have to drop the tank. But you know, a friend, a shade tree mechanic, especially if you can help out a little bit, bring some beer, you know, stuff like that. They'll usually be a lot better for that. But yeah, in almost all cars, the fuel pump is in the fuel tank. So there's this entire assembly. At the top of the fuel tank is a ring, and this entire assembly pops out, and in that assembly is the fuel. I'm gonna explain for everybody else. I know you know, but for everybody else who doesn't know, it's always in the tank. Now, if it's a pickup truck, you might be able to do what we did and not have to drop the tank at all. If you can pinpoint exactly where the tank is, and if it's in an optimal position, you can cut a hole in the bed of the pickup truck right over the fuel pump. And if you get it right, you'll be able to jigsaw a hole right where it is, and you'll be able to reach down and start taking it apart and pull everything out without having to drop the tank. We were able to do that because, you know, our buddy had a welder, so we were able to weld a patch over that, and then the bed liner covered it so you didn't see it. But this way we had an access patch to access the fuel pump, because we had to change every fuel pump in every car we own when our government thought it was great to force ethanol 10% fuel on us, and it destroyed every fuel pump in every car we own. But yay, corn industry that does absolutely nothing, because now we burn more gas. But it's 10% ethanol. No, we burn more gas on top of the 10% ethanol. Wow. Nice. Good for you. I like when people do stuff like that. Oh, they're beautiful too. Nice job. Absolutely. Oh, is that the sunset orange from Atomic Filament? That one right there looks like Atomic Filament's sunset orange. It is one of my all-time favorite filaments. It is so beautiful. But if it's not, it looks just like it. Beautiful, beautiful. Absolutely gorgeous. And the corn industry. Silk orange from Globotop 3D. Okay. It looks just like the silk sunset orange from Atomic 3D. From Atomic Filament. I love their filament. I tried to get them to sponsor a project for Armorf. They said they're not doing that right now. No blame on them. I like their filament, and I wanted to show it off there. I just don't have any more of it. If I had more of their filament, I would do it just to promote them, because I love their stuff. Now you see, none of these look like that. This is probably the one you did right here. But that looks different than the picture. So it must just be a picture variation. Let me show you. I mean, obviously you're not lying. So it's just a variation in the picture. But still, gorgeous print. I don't even have an affiliate link for Atomic. I wish I did, because I love promoting their filament. Let's see here. Silky effect. Yeah, I did. I went to the silk section. There it is. Sunset. Yeah, it is pretty similar. Yeah, that's very similar. Oh, it's damn near identical. The Atomic is slightly less silky, which I actually prefer. I'm hoping Polymaker will send me some co-extrusion because I really want to print a rocket with co-extrusion, but I can't use silk. At least I really shouldn't use silk because the silk will delaminate, and I think it'll delaminate when the ejection charge pressurizes the rocket. And if it doesn't delaminate when the rocket pressurizes at the ejection charge, it'll probably break when it hits the ground. Because I think silk would make an amazing looking rocket. It's just the layer bonding is not good enough. However, Polymaker is coming out with a co-extrusion that doesn't use silk. It uses regular PLA. And it's especially ideal for rockets because it's phase mode. So the external perimeter of the rocket is always printed in the same direction. It reverses direction when it goes inside and outside, but the outside is always the same direction, which means it'll maintain the co-extrusion effect. The co-extrusion effect works best on objects where the external perimeter is always printed in the same direction, because the way the co-extrusion works is you have the best way to describe it is, let me show you. So let's say I have 3 colors. I have purple, I have blue, and I have silver as a co-extrusion, okay? So the way the co-extrusion works is depending on what direction you're moving depends on which color is going to be dominant. So for example, when you're going this way, this blue is going to be dominant, but then when you come around this side, the silver is going to be dominant, and then when you come around this side, the blue is going to be dominant. So if you're going back and forth in different directions all the time, you lose the effect. It looks like static lines. But if you print something in phase mode, then from one angle it looks like in one color, and as you rotate it, it changes color as you rotate the extrusion. So I need 2 things from them. I either need a 3 to 5 kilogram roll so that I have one continuous extrusion for all the parts, or I need consecutive rolls. I need a co-extrusion, but even consecutive rolls might not work. It needs to be one long strand, because if you unload the filament and then reload the filament, you're going to change the orientation the filament went into the printer, and you're going to get a different extrusion. So what I really need is a large roll of co-extrusion filament, so that because I have to print the rocket in multiple parts. And so just like printing the clear one, for anybody who wasn't here earlier, who didn't see that, this is what I held on to that roll all that time for, was to print this. Because I needed a rocket where I can print one part after another. Ooh, that's why I was popping out. I needed to be able to print one part after another, and I needed to be able to print the parts consecutively and in the same orientation. See, sometimes I print a part upside down. That would break the effect. Because I printed these 3 parts consecutively in order, in the same orientation, the effect moves up the rocket in one continuous, constant color change. And the effect is awesome. All right. See you later, Ben. Ben, something you might want to try temporarily to fix your truck. I don't know if this will work. It doesn't always work. It depends on the design of the fuel pump. But you might be able to put an external fuel pump in the car. So cut the fuel line and put an inline 12-volt fuel pump inline on the outside of the fuel tank. That might get you running. Maybe. We had to do that to a car once. Didn't that come out great? Imagine that's transparent. You can see through that. Imagine that in the sun. Oh, it's gonna be great. That's gonna be so good in the sunlight. And but I want to do that with co-extrusion. And a rocket, vase mode rocket, is perfect for it because the external perimeter is always in the same direction. It's always, without exception, going to be clockwise or counterclockwise. The only trick is I got to make sure it's the same direction from part to part, because it is possible for it to reverse on a second part. So I'll have to, but I can adjust that by changing the start point in the slicer. I can alter the start point to to make sure it's always going the same direction. I can look in the slicer and make sure, or just print a test piece and make sure it's actually going the right way. But as long as I make sure the co-extrusion moves in the same direction, that co-extrusion effect will move up the rocket. It'll be very cool. Let's see. What was that? I don't know if you can still hear me, George. The ME40, the printer itself is reliable. I have put well over 100 kilograms of plastic through this printer. Well, maybe not 100, maybe 50 or 60. I've put 50 or 60 kilograms of plastic through this printer. Different size nozzles, very reliable machine. But it does have one problem. The interface is a little bit lackluster. You can't access certain things that you should be able to access. For example, micro-stepping. There's no micro-stepping. And the automatic bed leveling does not work. It is just inconsistent and not reliable. It creates a mesh. The mesh is good, but the offset never sticks properly. Now, that's actually easy for me to deal with. It only has a single lead screw. I just grab the goddamn stepper and turn it. It's easy. It's not hard. I make my first layer slow while it's printing the skirt. I grab the coupler motor on the stepper motor and I go, and I turn it, whatever number of turns I need to turn to put the nozzle where I need it. And then it's going. I only have to do that once every 24 hours because each of these prints takes a day. So it's not turnkey. You're not going to be able to just hit go. Now, besides that problem, it is reliable. The machine is consistent. It's solid. It's reliable. It hasn't given me any issues. No electronic problems. No glitching problems. It just works. It's a good, decent machine. One other problem it has, the feeder unit is plastic. And the input for the feeder, which I now realize I think had an opening big enough for a PTFE tube, and I've already destroyed it. But anyway, the filament started to cut into the feeder unit. And so I had to nip away at the excess plastic. But beyond that, good machine. It's reliable. I get clean prints. Every single rocket you see here came off of that printer. Every one. The Aquarius came off of that. All these purple rockets came off of this. All of these big rockets, these colorful rockets, every rocket you see here, all of this came off this machine. Every single one. All of these tubes I'm printing, all of this. This all came off of the ME40. It's a solid machine. The issue is firmware. It's got shoddy software. And the core issue with the software, here's a simple bug that's annoying. It doesn't make the machine unusable, but it's annoying. When you go to preheat the system, you can't preheat the nozzle above 200 degrees. You can set it above 200 degrees, it just won't do it. It just stops at 200. Now, of course, when you put your G code in there, right now I'm printing at 220, and I printed that PETG model at 245. So it'll go higher, but the preheat function on the screen won't go higher than 200. And that's really annoying when you're trying to change back from PETG to PLA, because you need to go to 240 to clear out all the PETG. And then, of course, no baby stepping, micro stepping for the bed leveling. And it being inconsistent. Like, you set it, and then it goes somewhere else. It's like there's an offset somewhere in the firmware set incorrectly. But beyond that, it's a great machine. If you can get one cheap enough, I'd definitely say get one. If it's cheap enough. Because otherwise, mechanically, I've had no issues. But again, it's not going to be a turnkey machine. This is not going to be a set it and forget it like your Ender 5 will be once it gets set up properly. My Ender 5s are set it and forget it. Once I turn them on, I can just hit print and walk away. This will never be that. But it's great for printing big stuff. But it's a 334 like any other 334. I don't know. I'll have to contact them again. I haven't talked to them in a while. I'll have to see if they have any updated firmware. Because that's all it needs. It's not a hardware issue. It's a firmware issue. You know, they need to add, more options to the firmware for us to change settings. They need to fix it so I can set whatever temperature I want for preheat. Stop defaulting to 80 degrees Celsius for bed heat up. I almost never need the bed to preheat to 80 degrees, but that's its default. It always defaults to 80. The big thing is fixing the auto bed leveling. And again, that's a firmware issue. If they fix that, that would change everything. This would be a much better printer if they fix that. But beyond that bed leveling thing, it's really a non-issue. It holds the bed level once you set it. I've never had to readjust it. Although I probably should change out those springs to the die compression springs, just because the circle cut springs kind of suck. But I did replace the sticker with a grippier build surface. This came with a PC build surface, the smooth polycarbonate build surface. Well, I prefer the ones that have a texture, that have a grip and a hold when they're cold. So I replaced the sticker on it, but I used that first sticker for the first 30 kilograms of filament, and it was fine. Yeah, but otherwise I haven't had any issues. I mean, it's a trooper. It just keeps going. Like I said, it's been sitting here on this desk for the last, year? And I'm back down to a 0.4 millimeter nozzle because I want to print these really big lightweight parts. I printed this on it. I printed this on it. I printed this on it. I printed all these purple rockets on it. I printed these were printed on the CR6SE. The little silver ones were printed on the CR6SE. My snake was printed back there. Making a mess. All the other fin units I've been printing, they were printed on there. Everything big. All of this big giant rockets you see here, there's 1, 2, 3, 4, 5 rockets here. They were all printed on this. Wait a minute. I think the red one. No, the silver one. This silver one I printed on the CR6SE. But the gray one, the red one, the multicolor one, the brown one, all printed on there. And the big nose cone, that was printed on here. The big sections of body tube I'm making. That big 900 gram silky blue tube fin rocket that I'm working on, that was printed on here. With a 0.6 millimeter nozzle. So, it's definitely, this vase was printed on here. This cool wood vase, that was printed on here. So it's definitely a decent machine, but it's not perfect. Definitely not perfect. So, yeah. When you don't have the resources, you limit how far you go. So I don't take long trips because I can't afford the consequences if something goes wrong. Flying, sure, if I have the money, I could fly. But, because you can always get your plane ticket home, right? But driving, that you have to absorb a lot of risk. A lot more than I can afford now. So I was saying before, I found this guy on Printables who makes these beautiful dishes, vases, organizers, cup holders in rope and basket themes, which would sell, I think they would sell well here. And he has very generously permitted commercial usage. So his license allows commercial use because I obey the license that people put on their works. Yeah, I would actually be okay if I wasn't carrying all this debt from my dad. If I wasn't carrying all this debt from my dad, I would be okay. I mean, I would still be in the same money situation, where I couldn't do much because I have no money, but at least I wouldn't be ruining my credit and defaulting because I wouldn't have any debt. Just shit happens, You deal with it, you move on. That's all you can do. Just do the best you can and try to make better of it. Can we see the printer? You're not going to see much. It's a bit close. So I changed this print surface. It came with the steel flex plate, but I put a new sticker on it. This is the part it's currently printing. And it does it all in vase mode. See my stacks of filament, I keep changing colors depending on what I'm printing. And it's quiet. Although the fan inside the base is starting to get noisy. It starts off noisy and then it gets quiet once it warms up. So it's a bushing fan. But otherwise, in general, you're hearing it when I'm talking. Now, when I'm not talking, the noise gate kicks in. But if I keep my voice nice and low to keep the noise gate from closing, you can hear the very little noise coming from the printer. No, it's a pretty quiet printer. Once it gets past that startup whine, I got to replace that fan. But this thing's basically been running 24/7 for the last year. I mean, I keep this printer busy. This is part 1 of the Starlight. So that is going to be this rocket here. This is the We Do ME40. That load in from Tinkercad is something else, isn't it? So we are currently printing this part here. And after I print that part, I'm going to print the fins to make sure they fit properly. And then I'll print the second part and the nose cone. This part should print quite a bit faster. It has a lot less plastic in it. But even this part's only like 150 grams. It's surprisingly, if you do it right, if you engineer structure, if you engineer structural integrity into the design of your model, it's surprising how light you can make them. Considering that it's all plastic. The whole thing is made of plastic, and yet it's that light. That's pretty neat. Like I said, this whole thing weighs 4.8 ounces. And it's all 3D printed. It's all plastic. I mean, obviously the weight has to be added for the tube. But, I mean, seriously? I mean, what does that weigh? 2 grams? That's all I have to add. Parachute, Kevlar, and this. That's all I have to add to it. So less than 5 ounces for an Aquarius. That's actually 115% scale. Which means it's almost exactly the weight it should be. If you scaled up the original one to 115%, it'd probably be like 4.7 ounces. This is 4.8 ounces. So it's only a half an ounce heavier than the paper one. Not bad. And if I print it with white filament, I don't need to paint it. So if I print another one, I'll print it in white. This way I don't have to paint it. And I just got to figure out how to get decals for it. Because I want to do one up. I want to do up all the decals on one of them. So that's cool. I just love that. This is a childhood favorite of mine. I was never wealthy enough to buy one because it's like $40 even back then. So this was always too expensive of a rocket for me to own. And by the time I had adult money, this was printed on, what printer printed this? This was printed on a CR6 SE, I think. I think this was printed on the CR6 SE. I'm pretty sure I printed this on the CR6 SE. Yeah, this is printed on the CR6 SE. The bigger one's going to be printed on the ME40. I think part of it might be this filament is lighter than normal. So we'll see when I try printing it with a different filament, because this filament feels a little lighter, but that could just be my imagination. You actually can't get this anymore. This was from a company called Color Me 3D. They're the ones who made the that really epic purple, that transparent purple filament. What was it called? There was a name for it. It was something purple. It was a really beautiful. The Chiron is dedicated to 1.2 millimeter prints. So I can't print a rocket with a 1.2 millimeter extrusion. It'd be heavy as a brick. If you can get a Chiron for $319, do it. The Chiron is a monster. The hot end is junk, but I got through several years with the stock hot end, and you can replace the hot end with a Creality style hot end. But besides the hot end being junk, the Chiron is a tank. It is one of my favorite printers. You could just beat the snot out of that thing. I was putting a kilogram a day through that printer. I was burning a kilogram of plastic a day. Each piece I printed weighed a kilogram. It took a whole roll. Because I was printing 1.2 millimeter extrusions with full 450 millimeter parts. So, I mean, I was burning the hell out of that printer, and it never even looked at me sideways. That printer is a tank. It is by far one of my favorite machines. It's probably my second most favorite machine, maybe third. My first most favorite machine is my Ender 2s. I don't care. I love my Ender 2s. They're always going to be my favorites. But my second, I would say it's a tie between my Ender 5 and my Chiron. But my Chiron is so reliable and it's such a trooper that I dedicate that to. It has a 1.2 millimeter nozzle on it. I don't change it. And that's just for my 1.2 millimeter prints. Yes, it does. It makes sense. It makes sense to have two printers. All right. You want one large printer for printing large things, and you want one regular printer. And there's a reason for that. First of all, you're probably going to end up putting a larger nozzle on the big printer, which is going to make printing smaller stuff annoying. But second, when you get that 4-day print going on the large printer, you're going to be really aggravated that you can't print anything for 4 days. And you will. You will get 4, 5, 6-day prints going. Or even at the minimum, these rocket parts, they're 1-day prints. They take 22 hours each. And it's going to drive you nuts when you just want to print a goddamn quick link, when you just want to print a goddamn stopper for under your sink, when you just want to print a nose cone for your glider, or you just want to print a little box to put some trinkets in, and you can't because you got a 3-day print on the big printer. You're going to love having that second printer. You're going to really love having that second printer. So your ideal setup is going to be a 334 and an Ender 3. So basically a CR10 and an Ender 3. And yeah, when you get more serious into fabricating stuff, yeah, you're eventually going to dedicate machines to different things. Like I said, I have a dedicated machine for 0.8 millimeter, a dedicated machine for 0.2 millimeter, and a dedicated machine for 1.2 millimeter. I'm probably going to build up a couple of dedicated Ender 2s. I'm probably going to have a 0.4 Ender 2, a 0.2 Ender 2, a 0.6 Ender 2, and a 1 millimeter Ender 2. I'm probably going to do that. I'm probably going to have I probably won't even need a 4. Maybe I won't even do a 4. Maybe I'll split the difference and do a 5. But I definitely want a 1 millimeter, a 0.6 millimeter, and a 0.2 millimeter. Because, first of all, a lot of times when you're printing 0.2 millimeter stuff, it's small. So the tiny Ender 2 is perfect for that. But it still has the Z height. You can still print 220 tall, which is a big deal for rockets, because rockets tend to be tall. But I also want a 0.6 and a 1 millimeter. So if I need parts on the field, I could fit all 3 of those printers in the car. And if I decide, okay, my I-205 Power Bird needs a new centering rig, well, I would rather not wait all day for the 0.4 millimeter nozzle to make me one strong enough. So I turn on the 1 millimeter Ender 2 and I have it in 20 minutes. because now I can do 0.6 millimeter layer heights with a 1 millimeter extrusion. I'll be able to spit out the nozzle and spit out the center in 20 or 30 minutes. But now you're getting specialized. Now you're getting very, very specialized. You're getting mission critical. You're starting to do things for particular missions. But for a general user, yeah, having an i3 size printer and a 334 printer makes a lot of sense. I'd even go so far as to add an Ender 2 Pro to that mix. You know, have your Ender 2 Pro, your Ender 3, and your 334. This way you can have 2 long projects going, but you can't really do a long project on an Ender 2. So it's always going to be available to print that little widget. You know, print that little thing. You know, that little tiny thing that you need that you could print in, 20 minutes to 2 hours. You know, something small. And it'll never get tied up in a multi-day print because it doesn't have a big enough volume to do a multi-day print. 334 is the bed volume. So add a 00 to each of those numbers. So 334 would be a 300 by 300 by 400. It's like saying it's a 65-inch class television. It's close to 65 inches. So a 334 is any of these machines with a roughly 300 by 300 by 400 print volume. Like the Ender 3 Max is a 333. It's 300 by 300 by 300. You could think of the Ender 3 as being, we call that i3 class, but it's basically a little over 2.5. 220, 220, 250. And it's easier to say a 334 printer than say 300 by 300 by 400 every time you want to say it. The Ender 2 would be subscale. That'd be sub-micro, sub-i3 scale. So it depends on which one you get. The original Ender could, if you tuned it correctly and you set your end stops correctly, you could print 152 millimeters by 161 millimeters by 224 millimeters on an Ender 2. Yes, you can theoretically do that if you align everything properly. But ostensibly, it's a 150, 150, 200. But it will go to 224. Ask me how I know. But but that's that's my reasoning. Now, if you do not print very often, Ender 3 is probably enough. Ooh. Most people don't actually print stuff this big. If you're going to get into 3D printing rockets, you're gonna want a bigger printer. You don't even necessarily need the 300 by 300, but you're gonna want the height. See, it's the difference between your rocket being made up of 2 of these, or your rocket being made up of 5 of these. You say, wait a minute, wouldn't that be 4? No, because you have the threads. You'll lose a chunk for each threaded section. So it's actually cumulative. You would need 5 of these to replace 2 of these. So having that 400 millimeter big volume build volume makes a big difference. I mean, this will fit on an Ender 2. It's only 117 millimeter diameter. An Ender 2 can do that. It's the height. That's what you need when you're starting to do rockets. The height allows you to make the rocket fewer parts. And fewer parts is good. Now, if you're printing small rockets, it's not a big deal. It's just not. Your segments will be that big. It's not a huge problem. But especially since you're probably going to want to change color as you go through those segments. But being able to print in fewer parts, like put it this way, the smaller printer to print this is 2 pieces. You have this section and you have this little section right here. But on a slightly bigger printer, I could print this as 1 piece. And so not a huge deal, but it is convenient when you're doing rockets to be able to print taller. So taller is good. I really want to extend a couple of these. It's not going to help for the smaller parts because you have wobble, and that wobble is going to decrease your print quality, which you're not going to want. But when you're printing something this stable, that's this big around, you can go taller without the quality problems because the part is stable. It's not going to wobble. This part, this part has a small footprint, so it tends to wobble, but it doesn't wobble this way very much. So you're actually better printing this off this way because now the bed moving back and forth is on the widest axis. But when you're printing a big fat tube like that or like this, you can go taller before you lose print quality. So I would like to have, I might even, I'll probably have to do it to the CR10S4 because I do not want to take the 1.2 millimeter nozzle off my Chiron. I like it with the 1.2, but I want 400 by 400. It's not so much that you need 400 by 400, but it allows me to have fins and still print in the print volume. It allows me to make one-piece parts. But what I want to do is I want to double the height to 800 millimeters. If I can double the height to 800 millimeters, then I could make, this is one piece instead of two pieces or three pieces. And there's both a weight savings and a convenience factor to making them one piece. Now, the advantage of multiple pieces is if you have a failure, you lose less. And if you damage it, it's easier to replace. But you balance that by having a heavier model that has more pieces. So it all depends. It's all wishy-washy. So, but still, being able to print larger pieces would be nice, especially nose cones. I do not like printing multi-part nose cones. They're a pain in the ass. Oh God, they're a pain in the ass. Try to split a nose cone so the two halves thread together. No, thank you. I just don't want to. That's such a goddamn pain in the ass. I just don't want to. So being able to print nose cones taller than 400 millimeters would be nice. At this scale, you're never going to have a nose cone that tall. There's really no need to have a nose cone bigger than 400 millimeters. But when you start getting into 5 and 6 inch class rockets, especially the 5 and 6 inch, you could very easily have, a 30-inch nose cone, depending on the design you're doing. If you want a long, slender, obligate ogive, whatever the hell you call that, if you want a nice, long, slender nose cone, scale that up 5 times, 6 times, 7 times, 8 times. All of a sudden, you're well past 400 millimeters. Also, if you want to make a really tall rocket, the fewer connections you have, the better, depending. Those connections can also add strength, but they also add mass. And well, the reason I use the ME40 so much is because it's here. It works. The ME40, it's reliable, it works, it's consistent, it does a good job. I have no reason to remove it from this table because it's doing what I need it to do. The Chiron is set up and it's doing what it does. I just haven't had any reason to print 1.2 millimeter parts lately. When I start making the bowls and stuff like that to try to sell, I might start using the Chiron again. But then again, the 0.6 millimeter nozzle will use half the filament and be just as strong for something like a bowl. So it'll be more cost effective to use a smaller nozzle for that. I use that for when I make my 6-7 foot tall models, like when I'm printing a full size person and I need it to be nice and stiff and strong and not take 10 days to print. Yeah, that's when I use the Chiron. Plus that heat bed takes so much power. Oh my God. It's 425 or 450 by 450 or something like that. It's a big, hungry heat bed. Oh, man. If there's a particular rocket you guys want me to model, I tend to lean toward models that I can vase mode, just because they're going to fly better. And I tend to like, interesting models, that like Aquarius, Starlight, Mars Probe, stuff like that. But they're also not ridiculous. Like, I don't want to print a Mercury Redstone or a Saturn V yet. They're just too complex. I want to keep it simple, something I do in 3 or 4 parts, something I can CAD up in a day or two. But if you guys see any interesting designs that look like they're vase mode compatible that you'd like me to model up, let me know. I've gotten multiple Mars landers done, the small one and the large one. I scaled it up. I've never flown one, though. But yeah, I've done a few of the MechG Mars landers. That's something you definitely want to download, George, is MechG's models. His models are amazing. I mean, they are absolutely balls to the wall phenomenal. But yeah, I've gotten them done, but I've never flown them. I need to. I need to remake one of each of his rockets to fly them. Because they're gorgeous. Oh, he has skills. He has serious skills. He knows what he's doing. Yeah, they're on Thingiverse. Let me find you one. Hang on. There it is. MechG. Yep. Hey, anybody wants to print rockets, you go to this guy. He's got some badass designs. I've printed the Bowmark. It's a nice print. He designed this for me. I asked him to make this for me, and he did it. I have not flown it yet. But I've always wanted to try to make the Cosmostrator fly. And so he modified it with a longer section here. I wanted it even longer, but still, he did a good job. This is beautiful. I can't wait to try to fly one of these. He's got a, what do you call that? Nike Apache. Here's an X. Ooh, I haven't printed the X15 yet. Nike Apache again. There's the Mars Lander. 2 different versions. This is a nice print. The Scale Arius. The Sentinel's a nice print. Nike Smoke. The A4V2. He has a lot of really nice models. And these are all made to theoretically fly. They all have motor mounts. And they're mostly single wall. Very, very, very nice models. He does a really good job on his models. Supports built in. So if it needs supports, they're built right into the model. I really want to fly this one. That's just such a cool model. And you do it just like he did here. You print that in a separate color, and most of your paint scheme's already done. Such a nice model. Absolutely gorgeous. Like I said, that one is really nice. A little more complex, but really nice. And another good one is the Aries. I really like the Aries. It's simple, it's fast, it's good looking. There you go. Relatively simple paint scheme. That's just a nice rocket. Everything's bayonet. So he designed this bayonet mount so that the parts snap lock together. See, everything's got bayonets. But he's a pro. He knows what he's doing. Okay? It all bayonet locks together. Absolutely gorgeous. There's the top tube. Yeah, there's not too many model rockets on Thingiverse that I'll say go get them. They're good. There's most of them are you know, person's first time in CAD software, and they're okay. But Mech G is he's like a step above the step above. He makes good stuff. Boy, that monoprice printer is a hell of a deal at $179. I just can't suggest anybody buy it without knowing more about it, though. Last thing I want to do is tell you guys to get something and it be garbage, you know? So, what I'm telling you is that assuming it's a decent printer, that's a hell of a deal for the price. Hey, TRT, how are you doing? Miss the gorilla? Who's the gorilla? I gotta clean out all these shelves. I hear a mouse back there getting into something. There's no food there, so I don't know what he's getting into. I think he's going after the packaging for the for nesting. Oh, I think they're going after the cardboard and the foam and stuff like that for nesting material. So I've got to clear out these shelves and find out what they're getting into and get rid of it. Because the cat can't get to them when they're in there. When they come out in the open, he gets them. Oh boy, does he get them. Oh, you guys want to see something funny? You're going to love this. Okay, the video is sideways, so you're going to have to deal with the fact that it's sideways. Is there any way to rotate the video? There's got to be a way to rotate the video. Video. I got zoom. I got aspect ratio. I got crop. But I don't see any way to rotate. I wonder, will View play these videos? Yes, it will. Ah, rotate's not available for video. Shit. Well, you'll have to watch it sideways. Pay attention now. The cats made a mess. They knocked a bunch of shit over. You can see it all here on the ground. They knocked over the trash can in my room. It's just plastic and bottles and stuff like that. And I turn on the light, and the cats just meander out of the room like it's nothing. I turn the light back off, and they're at it again doing something. And so this time I pull out the phone, and I turn on the thermal camera. And this is what I capture. You see that glowing spot there? You saw it peek out right there. See what he's got? There it is. Yeah, there it is. That's the two cats working together to fuck up a mouse. I moved, so he's looking at me. Look at him. That's a mouse they're screwing around with. It's neat how you can see the thermal reflection on the trash can. And you can see their paw prints in the carpet. There he is. His mouse trying to get away. How crazy is that? Oh, it gets better. I always wondered what the hell the cat is going on about in my bed. Sometimes he gets in bed with me and he's jumping all over the place. And I was like, that was after I recorded this video. I was like, no, don't tell me that's what he's been doing. Yes. He brought the mouse up onto my bed, and he was fucking this mouse up between my legs. That's a mouse right there. At first, I didn't see it, but you can see it right there. There it is. See him wiggling around? Yeah. He brought the mouse up on the bed, and he's fucking this mouse up in my bed. Eventually, he flicks it hard enough that it slams into the wall and goes down under the bed, and he goes crawling under there after it. I have crazy cats. Oh, that poor mouse. That mouse is probably just thinking, just put me out of my misery already. He made a run for it, and he didn't make it. Crazy freaking cat. I gotta put this through a video editor and rotate it. I didn't realize the thermal imager always vertical, no matter how you held the camera. Or maybe there's a setting for that. I don't know. That's the kitty cats for you. Crazy cats. What are you going to do? All right. I'm going to call it for the day. Thank you so much to both of you for supporting me so much. I appreciate that. You guys rock. I'm going to start making dinner. It's 4:30 in the afternoon here. And I haven't had breakfast yet. I am hungry. Ah, am I hungry. If I found one of them mice, I'd probably eat it. All right. My luck would be like Ender's Game, and he'd jump into my eye and tear my eyeball out and eat my brain from the outside. Remember how he beat the monster, the giant, in that virtual game? Yeah. That they ruined the movie. Oh. I was really annoyed by that. They totally didn't get it when they made that movie. They did not get the intent of those books. All right. I will hopefully have another video this Sunday of the different things that I've made for people who don't like the long form content, because this is a 5-hour video. And I will see you guys next week, and hopefully see some of you at the Rocky Mountain Murph. So you guys have a great day, and I will see you in a week.